In this lesson, we want to talk about the vertex form of a parabola. So we've already spent a lot of time working with quadratic functions, but we want to specifically learn how to graph a quadratic function. And in order to do that efficiently, we need to know about this vertex form, okay? So we're going to talk about that today. In case you're clueless about what a vertex is, we'll talk more about it in the next lesson when we're graphing. But basically, the vertex of a parabola is the lowest point if it's an upward-facing parabola, right? You get that standard U shape. And then it's the highest point if it's a downward-facing parabola. So if it's a U turned upside down. Again, we'll talk more about this in the next lesson. For now, we need to know how to convert between this form and this form. So something like f of x equals a times x squared plus bx plus c, where a is the coefficient for x squared, b is the coefficient for x to the first power, and c is your constant term. Now, most textbooks, most people will say this is standard form. This is going to vary based on which textbook you're using. Some textbooks will say this is standard form. So I don't want to confuse you, but I'm going to refer to this as standard form and this is vertex form. Okay, so this guy right here, this f of x equals, you have your a times the quantity x minus h squared plus k. The reason most people say this is vertex form is that you can immediately, upon inspection, find out where the vertex is. So the vertex will occur at h comma k. So this is my x coordinate, okay, and this is my y coordinate, right? So this would occur at h comma k. This would be my vertex for the parabola. So what we need to understand for today's lesson is how to go from this format here, this f of x equals x squared plus 12x plus 34 into vertex form, right? This is what I call standard form. We want to go into that vertex form, that f of x is equal to a times the quantity x minus h, and this is squared, and then plus k. So I want you to notice something. This is a binomial that's squared. So we know earlier in the course we talked about the fact that if you have a binomial squared and you go through the forward process, you get a perfect square trinomial, or a three-term polynomial that factors into this guy right here, a binomial squared. Remember, we can create this guy from the completing the square process. I know a lot of you guys are probably rusty on this, so let me just walk you through it. The first thing you need to make sure of is that the coefficient on the x squared here is a 1. So in this case, that's already done for us. Okay, so you don't need to do anything there. We'll see an example in a minute where it's not, but for right now, it's super easy. So the next thing you want to do is group your x squared term and your x to the first power term together. So I'm going to say I have f of x is equal to x squared plus, I have this 12x. So I'm just going to put parentheses around this for right now to say this is just in a group, and then plus my 34. Okay, so what I want to do now is complete the square. And let me just scroll down and get some room going. So I'm going to say I have f of x is equal to, I'm going to make this a little bit bigger, so x squared plus, I have my 12x, and then I'm going to add something here to complete the square, and then I'm going to subtract something here, and I'll explain this in a minute, and then I'll put plus 34 like this. Okay, so do you remember how to get this missing term right here? Remember, you take the variable that's raised to the first power, and you take the coefficient of that variable. So in this case, it's 12, right? That's the coefficient. You cut it in half, meaning you multiply by half, and you square it. So 12, if I cut that in half, or if I multiply by half, that's 6. 12 times 1/2 is 6. If I squared that, I would get what? I would get 36. Okay, so this is what I need to create my perfect square trinomial. So I'm going to add 36 right here. But I can't just do that. Normally, I would add 36 to both sides to make that legal. But in this case, I want this f of x over here on the left. I don't want to mess with that. So what I'm going to do is I'm going to subtract 36 as well. So 36 minus 36 is 0. I haven't changed anything mathematically. I can always add 0 to something. It's not going to change anything. So what I want to do now is close the parentheses down on this, okay? But normally, you have something out here that's multiplying this, and this creates an issue. Here, I just have parentheses here, so I can, at this point, just close the parentheses off like this and remove this from here, and I haven't done anything mathematically illegal. You have to be careful, though. If you have something out here that's multiplying this, then you've got to distribute, and we'll see an example of that in a moment. So for right now, what I've got is a perfect square trinomial here. So f of x equals, I can factor this into what? Well, it would be x plus, again, this guy was 6. Okay, so x plus 6, that quantity squared. And then over here, I just do negative 36 plus 34. That's going to give me negative 2. So I've found my vertex form. It's a little bit off, okay, but you can still write it this way. Remember, we said the vertex form was f of x equals a times the quantity x minus h squared plus k. So the reason I say it's a little bit off here is because of the signs. Here you have a plus and here you have a minus. Here you have a minus and here you have a plus. So if you wanted to find the vertex, you'd have to write it in this format or just know how to convert it off the top of your head, which most people do. But essentially you would just take this and say, okay, I'm going to match the format. So a is 1, so you don't need to write anything there. You can just say x minus a negative 6 is the same thing as plus 6. So now I have matched that minus sign there, okay? So minus a negative 6, and then this is squared, and then I'm going to do plus a negative 2, okay? So from here now I can just grab this guy right here and this guy right here, and I know my vertex occurs at negative 6, comma, negative 2. Okay, so that would be my vertex for this parabola. All right, let's look at another one. So this one will be a little bit more challenging because the coefficient on x squared is not 1. So we have f of x equals 2x squared plus 32x plus 123. So again, the first thing you have to do is make sure that this guy is a 1. Now, again, when you work with this, when you're solving quadratic equations by completing the square, you just divided everything by 2. But you don't want to do that, again, because you have this f of x over here. You don't want to mess with that. So what you're going to do now is you're going to factor it, okay? So I'm going to say that I have f of x is equal to, I'm going to factor a 2 out from this, again, first group. I'm going to treat these as a group, and I'm going to say I have 2 times the quantity. I'd have x squared there, and then plus, if I pulled out a 2 from there, I'd have 16x. Okay, so I've taken care of that. Okay, and let me just kind of scooch this down. I know I've got to add something and subtract something. And let me put my parentheses there, and let me put plus 123 there. Okay, so what are these two missing values here? Again, I just take this guy right here, this coefficient, look at the variable raised to the first power, we want that coefficient, cut it in half and square it. Okay, if you just say that a few times, you'll remember it forever. Cut it in half and square it. My 9th grade algebra teacher taught that to me, and I never forgot it. So if I cut 16 in half, I get 8. If I square 8, I get 64. So if I say 64 here and 64 here, okay, I have completed the square, but this is where it gets a little tricky and a lot of people make mistakes. Normally, if this guy isn't here, if this isn't a 2 here, I can just regroup this, okay? But because there's a 2 here, you got to realize that to remove the parentheses, we have to use the distributive property and multiply 2 by every term there, okay? But I don't want to do that. I just want to get rid of this part right here. So what I'm going to do is say that I have f of x is equal to, I'm going to keep my 2 out in front, so times the quantity x squared plus 16x plus 64. And then for this part right here, I'm just going to distribute the 2 to this so that I can remove it out of there, okay? And I'm going to say I have plus, and I'll do 2 times this negative 64. And then I'll wrap this up by saying it's plus 123, okay? So that's what you got to be careful of, okay? If you have something outside the parentheses like this 2 or whatever the number is, if it's not 1, you've got to do this extra step. It's a very common mistake to miss that. All right, so now what we want to do is write this. We'll say f of x equals 2 times the quantity. Okay, this guy would factor into what? It's x plus, we know that 64 came from us taking 8 and squaring it, so this would be 8, and this would be squared, and then we would have 2 times negative 64, which is negative 128, and then plus 123. We know that a negative 128 plus 123 would be negative 5. So this would be your vertex form. You have f of x equals 2 times the quantity x plus 8 squared and then minus 5. Again, if you want to match things up perfectly, you would write this as minus negative 8, okay? And you would write this as plus a negative 5. So I can just write that like that and say f of x is equal to 2 times the quantity x minus a negative 8, again squared, and then plus a negative 5. So the vertex here is going to occur at negative 8 and then comma negative 5. So negative 8, comma, negative 5. Again, this is your vertex. Okay, let's just do one more, and then I'll go into the super simple vertex formula, which is what you're going to use, but you might need to know how to do the completing the square method. It's always good to look at it because it comes up every so often. All right, so we have f of x equals 11x squared plus 66x plus 90. I'll kind of go through this very quickly. We know we want to factor that 11 out. So what I'm going to do is say this is f of x is equal to, I'm going to treat this, again, first 2 as a group. So 11 times the quantity x squared plus 6x, and then plus 90. Again, I'm just factoring the 11 out from the first 2 terms. All right, so let's go ahead and say this guy right here, I want to cut that in half, okay? Again, you're looking at the variable raised to the first power. Look at the coefficient. cut it in half and square it. Cut it in half and square it. So 6 divided by 2, or 6 times a half, is 3, and then 3 squared is 9. So what I'm going to do is I'm going to add 9. Okay, I'm going to add 9 inside of the parentheses. Now, if you wanted to get really advanced, I recommend just putting minus 9 inside of here so you remember to distribute. But if you can remember this on your own, you can just say that, okay, I have 11 times negative 9, okay? So it would be minus 99 out here. Okay, so I just kind of skipped the step there. Once you do this a few times, you're going to skip that step. You just have to make sure that you multiply 11 by the negative 9 so that it's the correct number. So then we have our plus 90 here, and we're ready to go. So what I can do is I can very quickly factor this and say this is f of x is equal to 11 times the quantity. This guy factors into what? X plus the 9 came from 3 squared, so 3, this quantity squared. And then negative 99 plus 90 would be minus 9. Okay, so that's your vertex form. Again, if you wanted to match it up perfectly, you would want this to be a minus and this to be a plus. So you'd say f of x is equal to 11 times the quantity x minus a negative 3. This is squared, and then plus a negative 9. So your vertex occurs where? Negative 3, comma negative 9. So the vertex, okay, the vertex is going to be at negative 3, comma negative 9. All right, so now let's talk about the vertex formula. And this is something that you're basically going to use. You're not going to complete the square every time. You're just going to do that if you're asked to do it. So we have this f of x equals ax squared plus bx plus c. Okay, again, you got to know that a is the coefficient for x squared, b is the coefficient for x, and c is the constant. We already know this from the quadratic formula, so it should be something that's familiar to you. And if you go through the process of completing the square to put this in vertex form, you would find that the vertex occurs at negative b over 2a, so this is your x coordinate, and then your y coordinate would be f of negative b over 2a. So in other words, find out what x is, and then once you have that, plug it in for x in your function, and you're going to get y as the result. So let's look at an example. All right, so here we have f of x equals 5x squared minus 20x plus 15. So if I wanted to find the vertex, what I would do is I would say that the x coordinate is negative b over 2a. So what is b and what is a? We know that a is the coefficient for x squared and b is the coefficient for x. Make sure you include any sign. So if it's minus, you want to put plus negative so you don't make a sign mistake. So the negative of negative 20 is 20, okay? And then 2 times a is 5, so this is 10. So this is 20 over 10, which is 2. So the x coordinate is 2. And then what we want to do is plug this in for x to find out our y coordinate. So in other words, we want to just know what is f of 2. So we would have 5 times 2 squared is 4. And then plus, you'd have negative 20 times 2, which is negative 40, and then plus 15. So I'll do 20 plus 15, which is 35, and then 35 plus negative 40 is negative 5. So this would be negative 5. So your vertex occurs at 2 comma negative 5. Okay, if you wanted to write this in vertex form, again, just match things up. It's f of x equals a times the quantity x minus h squared plus k. So h, again, is going to be your x coordinate. So this is the x coordinate. And k is your y coordinate. And I'm going to run off the screen, so let me kind of scooch that down. Okay, so what we want to do here is say that we have what? We have f of x equals, what's my a? What's this, right? It's the 5. So 5 times the quantity x minus, what's my h? It's the x coordinate. So from the vertex, my x coordinate is 2. And this quantity squared. And then plus, we have my y coordinate, which is k. Okay, so this is negative 5 in this particular case. So I can put plus negative 5 if I want, or I could just put minus 5. It doesn't really matter. So the vertex form here is f of x equals 5 times the quantity x minus 2 squared, and then minus 5. All right, let's just do one more of these. It's good to get a lot of practice because when you start graphing these things, you need to know how to do this off the top of your head. All right, so we have f of x equals negative 4x squared minus 64x minus 261. Again, the vertex will occur at negative b. B in this case is negative 64. So the negative of negative 64 is positive 64 over 2 times a. A is negative 4. 2 times negative 4 is negative 8. So 64 over negative 8 is negative 8. So the x coordinate is negative 8, And then again, to get the y coordinate, I want to do f of negative 8. So what is that? Well, negative 8 squared is 64. 64 times negative 4 is negative 256. And then you would have negative 64 times negative 8, which is positive 512. And then lastly, you'd have minus 261. So if you do negative 256 plus negative 261, you get negative 517. And then negative 517 plus 512 would, of course, be negative 5. So let's just go ahead and say this is negative 5. So we'll put negative 5 there. And I'll just go ahead and erase this. And again, if you wanted to write this in vertex form, you'd say f of x is equal to your a, which in this case is negative 4, times the quantity x minus whatever your x coordinate is from the vertex. In this case, it's negative 8. So you could put minus a negative 8 or you could put plus 8. It really doesn't matter. So this quantity is squared. And then you're going to have your plus k. K, again, is the y coordinate from the vertex. So this is negative 5. So you can put plus negative 5 or minus 5. It doesn't really matter. So your vertex form is going to be f of x equals negative 4 times the quantity x plus 8 squared and then minus 5. In this lesson, we want to talk about graphing parabolas. All right, so in the last lesson, we talked about the standard form and the vertex form of a parabola. We learned how to convert back and forth between the two. So again, I'm going to define this first one here, f of x equals a times x squared plus b times x plus c. I'm going to say this is standard form, and I'm going to say this guy right here, f of x equals the a times the quantity x minus h squared plus k. I'll say that's vertex form. Based on your textbook, it might be different. They might call this guy right here standard form, but I'm going to stick to calling that vertex form. So I don't want you to be confused by that. Now, when we talk about the vertex of a parabola, once again, it's the lowest point on an upward-facing parabola, or it's the highest point on a downward-facing parabola. Now, when we have our quadratic function in vertex form, what's special here is that we can get the vertex by just looking at the equation. So the vertex will occur at h comma k. So this is your x coordinate and this is your y coordinate. You can just pull it straight from here. So as long as it's in the minus form here and the plus form here, you just take your h and you take your k. Now, if you have different signs there, you have to make an adjustment for that, and we'll see that later on in the lesson. Now, let's kick things off by looking at a parabola that we've already seen before. So this guy is the simplest type of quadratic equation that you're going to come across. It is the f of x equals x squared that we already saw when we're talking about graphing transformations, okay? So we already know the points. We know that there's 0, 0, there's 1, 1, negative 1, 1, so on and so forth. 2, 4, negative 2, 4, and then 3, 9, negative 3, 9. You could do 4, 16, negative 4, 16, again, so on and so forth. Now, a couple of things to kind of pay attention to here. You can see that the vertex here occurs at 0, 0, okay? And if you wanted to write this in vertex form, you could play around with it and just say it's f of x is equal to, well, the a here, the coefficient of x squared is 1, so you don't have to put anything there. You would just say x, in this case, minus 0, that quantity squared, and then plus 0. Okay, and you're just doing this to show that this guy would be the x coordinate, and this guy would be the y coordinate, so the vertex would occur at, again, 0, 0, and that is your lowest point. Now, let's move on and talk about something else that's important when you look at a parabola. This vertical line that I've drawn in here that's basically going over the y-axis is known as the axis of symmetry, or you might also hear people say the line of symmetry, okay? So basically what this is, it's a line, and it's a vertical line to be specific, that intersects the vertex. So this guy is always going to be a line that is x equals whatever h is, okay? So again, h is the x coordinate of the vertex. In this case, it's 0. So this line here would be x equals 0, which is just the y-axis in this particular case. But basically what this guy does is it divides our parabola into two perfect halves. So I could take a point on one side of the parabola. Let's just say we took this point here, which is 3, 9, and I could fold it across that axis of symmetry, and I would touch this point exactly, which would be negative 3, 9. And we'll see this comes in handy when we're graphing, because if we get points on one side, we can kind of reflect them across that axis of symmetry and get points on the other side. All right, so now let's get into graphing a quadratic function, or you could say graphing a parabola. Basically, this is a very simple process. It only gets hard if the coefficient of this guy right here is a fraction, okay? If it's a whole number or an integer or something like that, it's very, very easy. I'm going to show you 3 different ways you can do this. The second method I'm going to show you is the quickest, but let's start out with kind of one of the more challenging methods, which is using graphing transformations. So in order to do this, we'd want to first write this in vertex form. So how do we do that quickly? Again, vertex form is f of x equals, you've got your a times the quantity x minus h, and this is squared, plus k. Well, again, a is the coefficient for x squared. In this case, that's 1. So if this is a 1, you can just get rid of that, okay? So what's h and what's k? Well, in the last lesson, we talked about a shortcut to figure that out, right? We saw that we could complete the square to get this, or there's a quick and easy formula we can use. So the vertex formula tells us that h occurs at negative b over 2a. Again, this is your a, the coefficient for x squared. This is your b, the coefficient for x to the first power. And this is your c. Okay, you don't need c here in this particular case, but I'm just labeling it for reference sake. So what is negative b over 2a? Well, b is 6, so I would have negative 6 over. For a, I have 1, so negative 6 over 2 times 1, which is 2. So this is negative 3. So this is the x-coordinate, okay, the x-coordinate for the vertex. So my vertex here will occur at negative 3, comma, and let me just put this in here. If I put minus a negative 3, that would be fine, or I can put plus 3 if you want as well. It doesn't matter, okay, as long as you know this is negative 3 for that coordinate. Okay, so the way we get k is we plug a negative 3 in for x in our function. Okay, so in other words, k is going to be equal to f of negative 3. And so we say we'd have x squared. So we'd plug in a negative 3 there. Negative 3 squared would be 9. And then plus 6 times negative 3, which would be negative 18. Okay, and then plus 8. Well, 9 plus 8 is 17. And 17 plus negative 18 is negative 1. So my vertex is going to occur at negative 3, comma, negative 1. So let's put minus 1 out here. Okay, so this is my quadratic function in vertex form. Okay, so we know the vertex is here. We know this is here. But in this particular case, we don't even need the vertex. We just need this guy here because we're going to use our graphing transformations. Okay, so we start out by comparing it to f of x equals x squared. Okay, so what do we have here? What happens inside? Well, we add 3. Remember, when you talk about what happens inside the function, you do the opposite. So if it's plus 3, you're shifting to the left by 3 units. So we would say that this guy is going to shift left 3 units, okay? And then this guy right here is happening outside the function. So this is your vertical shift, okay? And that's straightforward. If you have minus 1, I'm just shifting down by 1 unit. So we'll say shift down 1 unit. So we shift left 3 units and we shift down 1 unit. Okay, so we can take that graph, f of x equals x squared. We can do these shifts and we'll have our new graph. So let's go ahead and see that real quick. So I've already drawn these side by side for you. So again, you can take a point like this. This is 0, 0. You can go 1, 2, 3 units to the left and 1 unit down. I'm going to use a different color there. Let me use like a light or a dark blue. How about that? And let's just take this point here. So you go 1, 2, 3 units to the left, 1 unit down. Take this one, 1, 2, 3 units to the left, 1 unit down, so on and so forth. You can get this graph by, again, just applying shifts to the graph that you already know. So that's the first method. All right, let's talk about the easy method. This is the one that you're probably going to use in almost every case, unless you have a fraction as your value for a, in which case it becomes a little bit more challenging to use this guy. You might want to use a different method. All right, so again, we have this f of x equals x squared plus 6x plus 8. We already know that the vertex form is f of x equals 1 times the quantity x minus a negative 3, or you could say x plus 3, that quantity squared, and then plus negative 1, or again, you just say minus 1 if you want. So with this method, you basically want to find your vertex, which we already know it's negative 3, comma, negative 1. So your pattern is 1 times a, 3 times a, 5 times a, and 7 times a. Now in this particular case, again, a is the coefficient for x squared. It's right here and it's right there. It's implied there, okay? So we know a is 1, so 1 times 1 is 1. 3 times 1 is 3. 5 times 1 is 5. And 7 times 1 is 7. So this is the pattern. So first I would plot negative 3, comma, negative 1. So I'm going to go to negative 3, comma, negative 1. So that's right here, okay? And then I'm going to use that pattern, that 1, 3, 5, and 7. So what does this mean? basically what's going to happen here is I'm going to, as I move to the right 1 unit, I'm going to go up by this unit. So I'm going to go to the right 1, up 1, okay? Now the next time I go to the right 1, I'm going to use this guy right here. So to the right 1, up 1, 2, 3. Now the next time I do this, I'm going to go up 5. So to the right 1, up 1, 2, 3, 4, 5, okay? So you can continue. I'm going to go off my particular graph, but if you wanted to go to the right 1 and up 7, you could do that as well if you had enough room on your graph paper. So the idea here is that you can use that to get one side of the parabola. And again, your axis of symmetry here is x equals, again, what's the x coordinate for the vertex? Well, in this case, it's -3. So it's x equals -3. So that's your axis of symmetry. So I can use that to get these points on the other side. If I fold it across this line, just think about the fact from right here to right here is what? It's 1, 2, 3 units. So if I just go 1, 2, 3 units over here, there's my point, right? So here it's going to be 0, 8. And over here it's going to be -6, 8. Again, you could do the same thing with this point. You could take this and fold it across the line and get here. Take this, fold it across the line and get here. And then once you have enough points, you can sketch a pretty accurate graph. Let's talk about the third and final method that you can use, and then we'll just burst through a couple of problems. So again, we have the f of x equals x squared plus 6x plus 8, and in vertex form, the f of x equals 1 times the quantity x minus a -3 squared, and then plus a -1. Vertex occurring at -3, -1. We already know what this is. Now, in most textbooks, they're going to teach you to first find the vertex, which we have, and then they're going to tell you to find the x and y intercepts, and then they'll tell you to just grab additional points as needed. So you can use this method if you want. Again, it's in most textbooks. I found it to be pretty slow and inefficient overall, but we're going to go ahead and go through this just for the sake of completeness because your teacher might ask you to do this. So the first thing is, how do you get the y-intercept? Do you remember that's where you basically plug in a 0 for x, right? Because at the y-intercept, x is going to be 0 because you're crossing the y-axis. So in the standard form here on the top, I can just say, what is f of 0? Well, these two would be gone, and it would just be 8. So a point here, the y-intercept would be 0, 8. Okay, so that's something I would want to plot. Then I would find my x-intercepts. How do we do that? Well, we make y, or f of x, 0 now, because we're crossing the x-axis. So I would solve the equation, x squared plus 6x plus 8 is equal to 0. Okay, again, if you just replace this with y, and then you replace y with 0, this is nothing more than what we've been doing all along throughout all of algebra. And we come down here and we solve this by factoring. It's very, very easy to solve this guy. So this guy would factor into what? X here and x here. I've got two integers that sum to 6 and give me a product of 8. That would be 4 and 2. So plus 4 and plus 2. So the solutions here would be x equals -4 and -2. Okay, so that tells me that the x-intercepts are going to be at -4, 0, and then also at -2, 0. So let's erase all this. And again, we could just plot these points. And let me just paste this in here real quick. And I'll write this more neatly. So we have 0, 8. We have -4, 0. Let me make that better. And of course, we have -2, 0. Okay, so let's erase this. All right. So we know the vertex occurs at -3, -1. So -3, -1. We have our axis of symmetry. Again, that's x equals -3. And then we just plot these points. So we have 0, 8. So 0, 8 is here. And you can reflect this across the axis of symmetry to get this point over here, this -6, 8. Then you have your two x-intercepts. So you have your -4, 0 and your -2, 0. So you don't get these 2 points from this method. Okay, so you'd be sketching the graph with just these 5 points, which can still give you a pretty accurate sketch of what's going on. In most cases, these things, your teacher's not asking you to be perfect. Just give them an accurate sketch of what's going on. We know in this day and age that we can pull up any graph from an online calculator in a millisecond. So the idea is just to show that you know how to perform this task. Okay, let's look at 2 more problems, and I'm going to do these using the quick and easy method because in most cases, you're just going to do this. Again, unless you get a fraction for this value here for a, right, you can use this method. It's very, very effective. So we have f of x equals 2x squared minus 8x plus 6. So the first thing I want to do is put this in vertex form and grab my vertex, and then I want to think about that pattern, okay? So I would have f of x is equal to, again, a times the quantity x minus h, this is squared, and then plus k. So what is h? What is k? We know a is 2, right? It's the coefficient of x squared. So let's put a 2 in there. And again, for my h is equal to negative b over 2a. Well, what is negative b? Well, b is this guy right here. Include the sign, so negative 8. So the negative of negative 8. So make sure you don't make a sign mistake. You've got a negative there. You've got a negative 8 there. So the negative of negative 8, which would be positive 8, over 2 times a. A in this case is 2. So the negative of negative 8 is 8. So that's 8 over 2 times 2 is 4. So this is 2. Okay, so this guy would be 2. And that would be the x-coordinate for our vertex. So let me erase this real quick. And let me write this over here. So the vertex, we already know the x-coordinate is at 2. And then what about my y-coordinate? Again, to find that, I just plug a 2 in for x in my function. So what is f of 2, right? This would give me my k. This is what? It's going to be 2 squared, which is 4, times 2, which is 8, minus 8 times 2, which is 16. So let me just go ahead and write that. Let me just put minus 16. And then plus 6. So negative 16 plus 6 is going to be negative 10. And if I did 8 minus 10, that's negative 2. So this is negative 2. This is negative 2. And again, I can put plus negative 2, or I can just put minus 2. It doesn't really matter. Now, what I want to do now is just grab my vertex. So 2 comma negative 2. So my vertex is 2. Let me make that better. So 2 comma negative 2. So 2, negative 2. That's going to be right there. My axis of symmetry is x equals 2. So you see that line is already drawn. And basically what I want to do now is just use my pattern. Okay, so remember it's 1a, 3a, 5a, 7a, so on and so forth. Now, in this particular case, a is not 1. So you have to be careful because you can kind of think about this as 1, 3, 5, 7 for the easy examples when a is 1, but when a changes, you've got to pay attention. So if we come back up here, remember a is 2. It's the coefficient for x squared. So when we come back down here, the pattern's going to change. 1 times 2 is 2. 3 times 2 is 6. 5 times 2 is 10. 7 times 2 is 14. So what this is telling me is that when I move to the right 1 unit, I've got to go up 2 units. So to the right 1, up 2. Okay, so that's a point. Then if I move to the right 1 unit, I've now got to go up 6 units. So to the right 1, up 6. So that puts me there. Now, again, I'm going to run off the graph, but if I went to the right 1 unit, I would need to go up 10 units now to get to my next point on the graph. Now, we don't need this because, again, I'm off my particular graph, but if you were using some kind of long graph paper, then you can go through and get as many additional points as you want using this method. So I've got 3 points here, and I'm just going to reflect across this axis of symmetry to get this point here, right? Because again, the distance from here to here, this is 1, 2 units away. So this is going to be 1, 2 units away. From here to here, this is 1 unit away. So this will be 1 unit away. Again, you just reflect across that axis of symmetry to get those other points, and then you can draw a sketch of that graph. Let's do one more of these. I think it's useful to look at an upside down parabola. So we have f of x equals negative 2x squared minus 12x minus 16. So again, write it in vertex form. So f of x is equal to a times the quantity x minus h squared and then plus k. All right, a is negative 2 here. So let's go ahead and write that in. So we'll say this is negative 2. And then what's my h, what's my k? We already know that h is what? It's negative b over 2a. So what's b? b is negative 12. So the negative of negative 12 is 12. Over 2 times negative 2, which is negative 4. So this is going to be negative 3. Okay, so again, minus a negative 3 is plus 3. So you can put plus 3 in there if you want. But remember, when you write the vertex, when you say this is the vertex, you've got to put it in as negative 3. So negative 3. All right, so let's erase this. What is k? K is equal to what? It's f of whatever this guy was. Again, you're not putting in a positive 3. You're using this coordinate here, which is negative 3. So f of negative 3. These are just common mistakes, things that you'll find yourself doing when you first start, when you're not really paying attention. So you got to pay close attention to the signs. So f of negative 3 is what? Well, we'd have negative 3 squared, which is 9. 9 times negative 2 is negative 18. And then you'd have a negative 12 times a negative 3, which is plus 36. And then you'd have minus 16. Okay, well, 36 minus 16 is 20. And then if you did negative 18 plus 20, that's positive 2. Okay, so this is going to be 2 here. So let's write this down here. So it's negative 3 comma 2. So negative 3 comma 2. Again, that's my vertex. And let's go ahead and write this as a 2 right there, like that. So let's go ahead and plot negative 3 comma 2. So we would have negative 3 comma 2 is right there. So that's your vertex. Then again, your axis of symmetry is going to go through that vertex. So we would say this is x equals, the x coordinate is negative 3. So x equals negative 3 is the axis of symmetry. Okay, so again, the step pattern is what you want to have. So you have 1a, 3a, 5a. In this particular case, you don't need to keep writing these out because you're only going to get 2 additional points out of this because my graph only goes down to negative 10. Okay, so we know a, if I go back, is negative 2. Again, it's always the coefficient of x squared. So 1 times negative 2 is negative 2. 3 times negative 2 is negative 6. And 5 times negative 2 is negative 10. Okay, so what you want to do is say, okay, if I go to the right one, I'm going to go down by 2 because it's a negative 2. So to the right one, down 2. Now to the right one, the next one is negative 6. To the right one, down 6 units. Okay, so that puts me there. Again, if you wanted to go to the right one again, you would fall by 10 units to get to the next point. For myself, on this graph, I can't do that. I would run out of room. Okay, so I can only put these 2 points in. So it's very important to remember with this kind of pattern that, again, it's 1a, 3a, 5a, 7a, so on and so forth. Make sure you do the multiplication by a. Otherwise, you're going to get the wrong answer if a is not equal to 1. Okay, so you've got to pay close attention to that. We get lulled to sleep by these kind of easier examples where a is equal to 1. Then we get the harder examples and we don't know what to do, or we just get the wrong answer. Now, once you have these points over here, again, you can reflect them across this axis of symmetry. Again, this is 1 unit away, so this will be 1 unit away. This is 2 units away, so this will be 2 units away. And from that, you can have your graph. In this lesson, we want to talk about graphing horizontal parabolas. All right, so we've already talked about how to graph a vertical parabola. Now we just want to follow up and talk about how to graph a horizontal parabola. So of course, with a vertical parabola, it opens up or down. And with a horizontal parabola, it's going to open to the left or to the right. So let's start with something that we know. We know this is the vertex form for a parabola that opens up or down. So we've already seen this. The f of x equals a times the quantity x minus h squared plus k. So most books call this the vertex form. Some will call it the standard form. I'm going to refer to it as the vertex form. Now, in a lot of cases, you need to be able to go from this standard form, the ax squared plus bx plus c, to this form here. The reason you want to do that is because in this form here, the vertex form, the vertex is given as h comma k. So you can immediately see that. You can also see a, which you can see here as well, but a tells you whether this guy opens up or down. If a is positive, it opens up. If it's negative, it opens down. Additionally, you're going to be using a with that little step pattern that we talked about when we discussed graphing parabolas. We'll go over that in a moment if you never learned it. All right, so we know that to go from this form to this form, we can use the completing the square method, or we can use the vertex formula. So this h is found as negative b over 2a. So I can just take, again, this is b, the coefficient for x to the first power. This is a, the coefficient for x squared. So that gives me h, or my x coordinate for the vertex. And then what happens is once I have that, I can plug in whatever that value is in for x in my function, okay, and I can find out what y is. So you could really just say that for k, it's f of h, okay, because all I'm doing is I'm plugging this in, whatever h is, in for x in that function to find out the y value for the vertex. Now, what I want to do is talk a little bit about going into this horizontal parabola or the sideways parabola. So all I did here for this top one is I wrote y instead of f of x, and I subtracted k away from each side of the equation, okay? For this one, this is the sideways parabola, and I want to just show you that the roles of x minus h have kind of been swapped, right? So here it's inside of parentheses, now it's outside. And then y minus k, it's been swapped, right? It's been coming inside of parentheses from outside of parentheses. So you can say that the x minus h and the y minus k, those guys have really interchanged roles. So we're going to have to think about things a little bit differently here, okay? So I can solve this for x Let's say this is a times the quantity y minus k squared, and then plus h. Now, what I need to know here is how to go from this form to this form, okay? Because this is going to come up immediately. Again, we want to put it in this form because when it's in this form, the vertex is still going to be given as h comma k. Okay, so it's still those, h is here now and k is here now. Okay, so they're in different positions, but it's still the same letters so that we understand what h is. It's the x coordinate for the vertex. What k is, it's the y coordinate for the vertex. Now, another thing you need to understand is that a now is going to tell you if it opens to the right or to the left. If a is positive, it's going to open to the right. If a is negative, it's going to open to the left. So the vertex formula that we talked about a minute ago, where we said h was equal to negative b over 2a, well now, since the x and the y's have swapped roles, this isn't going to be h anymore, now it's going to be k. So that's how you find k, and once you have that, you can plug in for y, okay, and then you can find your x coordinate. Now let's go ahead and just look at an example. This isn't too tough. So we have x equals 2y squared plus 4y minus 3. So I want to start by putting this in the format of x equals a times the quantity y minus k squared plus h. Again, you can complete the square if you want. If you prefer that, that's fine. For myself, I like the quick method. So now I know that k is going to be found as negative b over 2a. So what is b in this case? Again, this is a, it's the coefficient for y squared. This is b, is the coefficient for y to the first power. And you can label this as c if you wanted to. You don't really need it here, so I'm just not going to do it. So what I'd have is negative 4. So negative 4 over, what's a? A is 2. So 2 times 2 is 4. So this is negative 1. Okay, so I could write this as x equals, I know what a is, that's 2, times the quantity y minus the negative 1. And you can put plus 1, but for the sake of matching this up, I'm going to put minus a negative 1 here. And then plus, we still need our h. Okay, so how do we get that? Again, you just plug in. All right, so I'm going to plug in a negative 1 there and there. So what would that give me? X is equal to, negative 1 squared is 1, 2 times 1 is 2. And then negative 1 times 4 is minus 4, and then minus 3. So 2 minus 4 is negative 2. Negative 2 minus 3 is negative 5. So I'm going to put plus negative 5 here. Okay, so now that we have this, we know the vertex occurs where? Again, it's h comma k. So h is negative 5 and k is negative 1. So if you write this as y plus 1 like this, you got to know that it's in the format of minus whatever k is, so you have to do that little transformation. Once you do this a bunch of times, it's something you could do mentally, but I want to write it like this so that it's very clear for you what h is and what k is. So we would plot negative 5 comma negative 1. So that's our first step. So we would go to negative 5 and then negative 1. So let me do this in a different color. So that's right there. And we know that a was positive, right? If I go back, a was 2, right? So since a is 2, let me just write that here. A is equal to 2. We know that this guy opens to the right. Again, if it was negative, it would open to the left. Additionally, we know about this axis here, which kind of splits the parabola into 2 equal halves, right? So in this case, now it's going to be y equals negative 1, right? So y equals negative 1. So the reason you know that is now it's going to be a horizontal line, okay, whereas before it was a vertical line, and that guy is always going to intersect the vertex. So if it's a horizontal line, it's going to have y equals something, and it's going to be your y coordinate from the vertex. So in this case, it's negative 1. And let me just erase this. We don't really need that. So now, we've plotted our vertex. Again, that's negative 5 comma negative 1. What we want to do now is use that step pattern. So remember, it's that 1, 3, 5, 7, 9, so on and so forth. So what we do is we multiply our a value by each one of these. So 1 times 2 is 2. Then 2 times 3 is 6. Then 2 times 5 is 10. And we don't need to keep going because we're not going to be able to get all these points in. But basically before, what you would do is you would say, okay, I go 1 unit to the right, and then I go this many units up, okay? But now, since things are changed, now what I'm going to do is I'm going to go 1 unit up and this many units to the right. So I'm going to go 1 unit up and 2 units to the right. So that puts me here. Then I'm going to go 1 unit up, and I'm going to go 6 units to the right. So that would put me here. Then if I wanted to kind of expand this, I'm not going to be able to fit it here, but you could on your paper. You could go 1 unit up, and you could go 10 units to the right. So that would put you at 13 for the x value and 2 for the y value, okay? So once you have these points, you can just reflect across that axis, okay? You know that from here to here is a distance of 1 unit, so you just flip it over here, okay? And then from here to here is 2 units, so you go 1, 2 this way. And again, once you have these points, it's very easy to sketch your graph. All right, let's just look at one more of these. I think this is something that you definitely will understand, especially if you already know how to graph a vertical parabola. It's basically the same process. So we have x equals negative 3y squared minus 18y minus 22. Okay. Again, if I want the format of x equals a times the quantity y minus k squared plus h, all I need to do to get my k value is say it's negative b over 2a, okay? So what is b? In this case, it's going to be negative 18. So be careful there. It's the negative of negative 18. So that's 18 over. What is 2a? A is negative 3. So 2 times negative 3 is negative 6. So this is going to be negative 3. Okay, so that's k, or the y coordinate for the vertex. So let me just put here that this is going to be negative 3. Now, to find h, again, I'm just going to plug in a negative 3 for y. So negative 3 squared is going to give me 9. Negative 3 times 9 would be negative 27. So let's say that x equals negative 27. And then negative 18 times negative 3 is 54. So let's go ahead and put plus 54 here, and then minus 22. So if I did negative 27 minus 22, I'd get negative 49. And if I add 54 to that, I'm going to get positive 5. So this h here is going to be 5. Okay, so we can write this as x is equal to, we know a is negative 3, times the quantity, let me make that better, y minus a negative 3, so you can put minus a negative 3, or you could just put plus 3, and then plus 5. But you would know that the vertex would occur at 5, okay, and then comma, you'd have your negative 3. So you take that, again, plot that point, and then use your step pattern. In this case, it's negative 3 for A, so you know it's going to open to the left. And let me just come to the sheet. So again, we have 5 comma negative 3. You can plot that really quickly. So here's 5 comma negative 3. And again, your axis is going to be y equals negative 3. So it's y equals whatever the y coordinate is for that vertex. Now, again, once you have that, you use your little step pattern. Your a here was negative 3. So that's what you're going to multiply by that pattern. So the 1, 3, 5, 7, 9, so on and so forth. So negative 3 times 1 is negative 3. And then negative 3 times 3 is negative 9. And we're not going to go any further than that, right? But you can keep going if you wanted to kind of make your paper a little bit longer. But basically what I'm going to do is I'm going to go up 1 and I'm going to go to the left 3, right? Negative 3 tells me I'm going to the left 3. So up 1 to the left, 1, 2, 3. So here's a point. And then the next one's negative 9. So up 1 to the left, 1, 2, 3, 4, 5, 6, 7, 8, 9. Arrive at that point. And again, you can just reflect these points across this axis to get this point here and this point here. So that's how you could sketch the graph of a horizontal parabola. In this lesson, we want to talk about conic sections. And here we're going to be focusing on parabolas. All right, so we've already spent a lot of time working with parabolas in the course. Now we're just going to go a bit deeper and explore a geometric definition. We'll also talk about 2 new terms, the focus and the directrix. All right, so let's start with what we know. We know that a vertical parabola looks like this. We have y equals a times the quantity x minus h squared plus k. So we know it's vertical because the x is involved in the squaring operation. And again, when it's in this form, we can say that h comma k is the vertex. Now, if a is greater than 0, it opens up. If a is less than 0, it opens down. We also have the horizontal parabola. So these guys open left or right. So x equals a times the quantity y minus k squared plus h. Vertex still occurs at h comma k, even though things are moved around. And again, we know it's a horizontal parabola because y is involved in the squaring operation. Now, here, if a is greater than 0, it opens to the right. If a is less than 0, it opens to the left. So we know this already. But what we want to do is develop this geometric definition for a parabola. This is something, again, you see in your textbook when you get to conic sections. So I've already graphed. This guy is y equals 1/8 x squared. So this is the example we're going to work with, okay? So we already know how to sketch the graph of this. That's nothing new for you. But what's probably new is this point here, okay, which is called a focus. Let me put an F there for focus. And this line down here, which is called the directrix, let me put a D here, okay? So when we have the official definition for parabola, it says that it's the set of all points where in this plane, they're equidistant from a fixed point F, which is the focus, and a fixed line D, which is your directrix. So you can pick, let's say, this point here to make it really simple and say, okay, what's the distance from here to here? And what's the distance from here to, let's say, here, okay? So this is 0, 2. This is 0, 2. And this right here is 4, 2, okay? And we can see that, let me kind of draw this line. Not perfect, but you can see this is a horizontal line here. And the distance from, if you think about this x-coordinate being 0 and this x-coordinate being 4, 4 minus 0 is 4. So the distance between those 2 points would be 4 units. Well, what we're saying is that the distance between this right here and this right here would also be 4 units. Okay, not a perfect line, but you get the idea. So this point right here, again, is 4, 2. And this point here would be what? It would be 4, -2. Okay, so 4, -2. So the distance here, this is a vertical line. So you think about 2 minus a -2, which is 2 plus 2, that's 4. So the distance from here to here is 4 units, and the distance from here to here is 4 units. So that's exactly what we're saying. Now, there's a lot of things to go through in this lesson. It's a really long lesson. It's a really detailed lesson. But what I want to start with would be just a few points, and then I'm going to derive an equation that we're going to use, and then we'll build on that. The first thing is the focus is always going to be inside of the parabola, okay? So if this focus is above the vertex, then you know that this guy opens up. If it's below the vertex, you know it opens down, okay? If it's to the right of the vertex, it opens to the right. If it's to the left of the vertex, it opens to the left. Okay, we're going to need that later on. Additionally, the directrix is always going to be outside of the parabola, okay? So what you can think about here is that the distance from here to here and the distance from here to here is always going to be the same, okay? So the distance from the focus to the vertex and from the vertex to the directrix is the same. In fact, this guy right here is the midpoint for the line segment that connects the focus to the directrix, okay? So you can see that from the focus to the vertex is 2 units. From the vertex to the directrix is 2 units as well. Okay, so a lot to throw at you. Now, what I want to do is use this kind of definition to derive a little equation. And this is something you're going to see in your book. It doesn't take that long, so I thought we could go through it. So let me come and pop back up here real quick. I'm going to call this, let me just erase all this. I'm going to call this right here 0, P. Okay, so we know the x location is 0. The y location, I'm just going to call it P, just generically. I'm going to call this point x, y, okay, generically. And I'm going to call this right here, we know the x location is the same. And the y location is the negative of P. Because again, this went up 2 units, this went down 2 units, so it's the negative of P. So if this is P, this is negative P. Okay. So now that we have these 3 points, we can say that F, our focus, is 0, P. We can say that our point P is x, y. And we can say that our directrix, okay, the point that we're working with is going to be x, negative P. Okay, so that's just a point on the directrix. The line itself is y equals negative P. But let's grab this real quick, cut it away. Let's come over here, and you'll see this in your book. So basically what we're saying is that the distance between the focus and the point, so between the focus and the point, is equal to the distance between the point and your directrix. Okay, so we know this. But we can show an equation by just doing this generically. Okay, and we're going to use this equation throughout our lesson. So what we'll do is we'll do our distance formula. So square root of, let's say this is the second point and this is the first point. So it's x sub 2 minus x sub 1. So x minus 0 is x, and that's squared. Then plus, it's y sub 2 minus y sub 1, quantity squared. So y minus p, quantity squared. Okay, so we've got that part set up. Then this is equal to, do the square root over here. So I'm going to call this 2 and this 1 now, and I'm just doing this for convenience. So I'm going to say x minus x is 0, and I'm going to say y minus the negative p is y plus p. So y plus p squared is all you'd have there, okay? Again, I don't have anything squared with the x because x minus x is 0, 0 squared is 0. Okay, so to kind of get rid of the square roots, I'm going to square both sides, and I'm going to be left with the radicand in each case. So I'm going to have that x squared plus, just go ahead and FOIL this out. This is going to be y squared, and then minus 2, and then you're going to have p times y, and then plus p squared equals, this guy would be y squared plus, you'd have 2py plus p squared. Okay, you can immediately get rid of this, and this, and this, and this, okay? Because again, same thing on each side of the equation, subtract it away, it's gone. Okay, so that's a piece of cake. So let's scroll down a little bit, and now what I'd have is x squared is equal to, if I add 2py to both sides of the equation, we would get 4py over here. So this is the equation you'll see in your book. You might see 4ay, just depends on what book you're using. But generically, you want to think about p. Let me kind of just bring this back up here. You want to think about p as this coordinate here, this y coordinate in this specific case, okay? Now this is going to change when we look at a horizontal parabola. In this case, we're looking at a vertical parabola, and we're looking at one specifically that has a vertex at 0, 0. So these formulas are going to change. But we'll get to that later. For right now, we can use this to derive this equation. So let's say I told you that the focus occurred at 0, 2. Okay, we would know that. Let's say we were given that and you said, hey, find the equation, find the directrix. Okay, well, the way you do this is you say that you have x squared is equal to, you've got your 4. The p is the only thing you get, and you get that from right here. This is p, okay? So it's 0, p. Well, in this case, p is 2. So 4 times 2, and then times y. So x squared equals 8y, or you can solve for y, and let me just erase all of this because it's in the way. You could solve for y by dividing both sides by 8, and you would get y equals 1/8 x squared, which is exactly what you have there, okay? So not a magic trick, nothing fancy there, just plugging in and simplifying. Okay, let's talk about a few things that we're going to find useful here. Let me just kind of erase all of this and start with something that's fresh. So when we talk about these formulas, again, in this case, it's x squared is equal to 4py, okay? So the focus is at 0, p, okay? The directrix is going to be y equals negative p. Again, you can think about this as the example. This is 0, 2, and this line here is y equals negative 2, okay? So this is always going to set up this way again, again, again. This is going to be the case where you have a vertical parabola and the vertex is at 0, 0. If your p ends up being negative, this guy's going to be upside down, okay? So your directrix is now going to be above the x-axis, okay? And your focus is going to be below, okay? So you just got to keep that in mind. All right, let's look at the first problem. This is a very easy problem, something that you're going to see. So they're going to ask you to find the equation, okay, with a focus of 0, negative 1/12 and a vertex of 0, 0. So again, what you're looking at here is your focus is 0, p, okay? In this case, I know I'm using this formula, okay? Later on, we'll see if the focus is p, 0, while I'm using the other formula for a horizontal parabola with a vertex of 0, 0. But we're not there yet. We'll get there in a second. For right now, we know this is the focus. We know the directrix, okay, is going to be y equals the negative of p. Well, p is this, negative 1/12, or negative 1/12. So it's the negative of that, so it's just 1/12, okay? Y equals 1/12. That's your directrix. So you're done there. For your equation, you just plug in. Very simple. Plug in for p, and I know it's a lot to remember, but x squared is going to equal 4 times 1/12, and it's negative, so 4 times negative 1/12. Times y. Okay, let me do this up here. We know that this cancels with this and gives me a 3 down there. So you could say x squared is equal to, you have your negative 1/3 y. Or of course, most of the time we want to solve for y. So we multiply both sides by negative 3, and you'd have that y is equal to negative 3x squared. So there's your equation. And again, you see that p is negative, and you know that you're going to open down, right? You know that if this right here, which is traditionally our a value, if that is negative, we know we open down. If it's positive, we know we open up. So again, for your focus, if it's 0, comma p and p is negative, you're opening down. If it's 0, comma p and p is positive, you're opening up. Okay, so another type of problem you're going to be given is you'll get an equation and they'll say, well, what's the focus? What's the directrix? Okay, so you've got to match things up to the form. Again, y equals 1/5 x squared. So I know that the vertex is 0, comma 0 here. Okay. Additionally, what else do I know? I know this is a vertical parabola. So I'm going to use this formula, x squared equals 4py. All I need to do is match things up. So right now, this is y equals something. I want x squared equals something. So multiply both sides by 5. You get 5y equals x squared. And then just match stuff up. I know that this is equal to this. Okay. So what I'd say is 4p is equal to 5. Again, I have x squared, I have x squared. I have y, I have y. It's the 5 and the 4p that get matched up, and you solve for p. Divide both sides by 4, and you get that p is equal to 5/4. So again, the focus is 0, comma p. Okay? It's 0, comma p. So the focus, 0, comma 5/4. The directrix, what is it? Y equals the negative of this, negative 5/4. It is a lot to take in and remember, but you write your notes, you do your practice, it will come. Okay, let's look at another scenario. So now what you'll notice is that your focus changed a bit. Now you have some value here for x, y is 0, okay? So this is the case where you're going to open horizontally, right? You're going to be to the right or to the left. Well, if this p value now is positive, you open to the right. If it's negative, you open to the left. So your focus in this case is some p value, comma 0, okay? Your directrix in this case is x, okay? Because it's opening, again, horizontally. So you're going to have a vertical line now, that's your directrix, right? Because it's behind the parabola. So x equals the negative of p, okay? So if we wanted to find the equation and the directrix, well, for the directrix, it's x equals the negative of this, so negative 1/80. That's it, you're done. For the equation, plug in for p. Again, this is 1/80. Okay, so times 4. This cancels, it gives me 20 down here. So really, I could just say this is y squared equals, you're going to have 1/20 times x. If you want to solve this for x, multiply both sides by 20, and you would say that x is equal to 20y squared. Okay, so one more of these, and then we'll go to the more challenging scenario where the vertex is not 0, comma 0. So you're given a point 1, comma 3. You're given a vertex, again, 0, comma 0. You're told that it has a horizontal axis. So you know this opens sideways, right? It's opening to the right or it's opening to the left. Okay, so what I want to think about is my formula. So it's y squared is equal to, you have your 4px. Okay, just plug in the point. So we're plugging in the point. So I plug in a 3 for y. I plug in a 1 for x. So you can just get rid of it, right? 3 squared is 9. So 9 equals 4p. Divide both sides by 4. And you get that p is equal to 9/4. Okay, so once you have that, okay, we already know what p is. So what is the focus? The focus, again, is p, comma 0, right? If it's horizontal. So it's going to be 9/4, comma 0, okay? The directrix is what? It's x equals the negative of this. So negative 9/4. Okay, so that's done. What about the equation itself? So we have y squared is equal to, you've got your 4 times p. P is 9/4. And then times your x. So what we'll do here is cancel this with this. You'll say you have y squared is equal to 9x. You can solve for x. Again, sometimes you want to do that. Just divide both sides by 9 or multiply by 1/9. So you would have that x is equal to 1/9 times y squared. Okay, now let's talk about the more challenging scenario. And this is where the vertex is not at 0, comma 0. So this involves a lot more thought. Okay, it's really not that bad once you do a few of these, but the first time you get to them, it's not obvious what's going on because your p-value, you have to calculate it now. Okay, it's not given to you. And the same goes with your directrix. So you have to kind of use your knowledge of what we talked about earlier in the lesson. So let's just go through this real quick. We know when x is involved in the squaring operation, it's a vertical parabola. We know when y is involved in the squaring operation, it's a horizontal parabola. So this is x minus h quantity squared equals 4p times the quantity y minus k. You have y minus k squared equals 4p times the quantity x minus h. So these are the two equations we're going to use. Okay, let's look at an example. So we're given the focus and we're given the vertex. And what we're going to be doing here is finding the directrix, and we're going to find our equation, okay, that matches the given information. Now, this is a lot more difficult, okay? So what do we do to start? We figure out, does it open up? Does it open down? Does it open left? Does it open right? First time you do this, it's a little bit challenging, but it gets a lot easier. So we know that the x value is the same in each case. If you see that, then you immediately know that it's vertical, okay? How do you know that? Well, just think about the coordinate plane real quick. If you do 2 on the x-axis, so that's right there, and that's the same, well, the only thing that's changing are the y-coordinates. Well, I'm changing vertically, okay? So that means that my vertex is at 2, let's say -1 is there, okay? And then my focus is at 2, and then it's going to be -1/2. Let's say that's right there, okay? Well, this guy's going to open up because the focus is above the vertex. Okay, so that's all you have to remember. You don't have to draw a picture each time. You know, if your focus is above the vertex, it opens up. If your focus is below the vertex, it opens down. Okay, it's just that simple. If your focus is to the right of the vertex, it opens to the right. If your focus is to the left of the vertex, it opens to the left. So now that we know that, okay, you know immediately that that p-value is greater than 0, okay, if it opens up, okay, and it's less than 0 if it opens down. So you got to remember that. So I'm just going to write here a note that p is greater than 0, okay? Now the next thing I'm going to do is write out my equation that I was given. So I know that I'm going to use the vertical one, so x minus h quantity squared. And then this equals, you've got your 4p times the quantity y minus k. Now, I plug in for h and k. The vertex, this is h, this is k. So don't get confused by that. H is the x coordinate, k is the y coordinate. Okay, so plug in here, plug in a 2. Plug in here, minus a -1, put +1, okay? So from this point, you might be thinking, well, how do I get a p? Because last time, we would just take 0, p, right? So a lot of you will say, okay, well, p is equal to -1/2. But that's not how you get that in this particular case, okay? What you want to do is think about that geometric definition that we talked about earlier. I know that the distance between the focus and the vertex is my p. If I go back to this example here, the distance from here to here, okay, this was 0, p. Okay, so this ended up being 2, so it's 0, 2. But this was my p. My p was 2, okay, because that's the distance. So coming back down, what I want to think about is the distance between this and this. Okay, just think about that. Don't worry about anything else. So what is the distance between -1/2 and -1? Okay, well, that's a half. Okay, and I know that it's convenient that it works out here in that particular case, but it doesn't always work that way. Okay, so you have to think about that. So the distance between this and this is 1/2. Okay, so my p-value, okay, I know it's positive because it opens up, is going to be equal to 1/2. Okay, and again, don't just take it from here. You've got to do the calculation. It's not always going to work out that way. I plug that in, and I'm basically good to go. I say x minus 2 quantity squared is equal to 4 times 1/2 is 2 times the quantity y plus 1. So you can leave it like this. Some teachers will accept it, or you might want to simplify it and solve for y. In that case, you just want to distribute this and say this is 2y plus 2. And let me erase that and just kind of drag this down. And then to solve for y, I'll say that we have 2y is equal to, I'll subtract 2 away from each side. So x minus 2 quantity squared, and then minus 2. And let me just erase this. And let me divide both sides by 2 now. And so what will that give me? This gets erased. You could really write this as y equals 1/2 times the quantity x minus 2 squared minus 1. Okay, so this would be the answer that I would give if I was in class. It's solve for y, and it's nice and neat. For the directrix, you have to think about the fact that the distance from here to here is going to be the same as the distance from there, the vertex, to the directrix. So this is a distance of 1/2 units, okay? And you got to think about the direction. So from the vertex to the focus, I traveled up, right? I went from -1 to -1/2. So for my directrix, I've got to travel in the opposite direction. Remember, the focus is inside, okay? The focus is inside, and the directrix is underneath, okay? So I'm going to go this direction now, so I'm going to subtract 1/2 away from -1. So -1 minus 1/2 would be negative 3/2, right? If I got a common denominator, this would be negative 2 over 2. Negative 2 over 2 minus 1/2 would be negative 3/2. So the directrix would be y equals negative 3/2. Okay, so I know that's a lot to take in, but let me just go over this one more time. You got to find p first. It's not just grabbing this guy right here, okay? You've got to think about the difference between this and this. It just happened to work out that way for this example, okay? So it's the difference between this and this, okay? So that gives you your p. Use that to plug in and get your equation. Again, the directrix, all you have to do is go in the opposite direction by that number of units. Okay, let's look at another example. I know this is super confusing. This is one of the ones that you just have to work a lot of examples. So the focus, 17/4 comma negative 7. The vertex, 4 comma negative 7. Okay, so in this particular case, how do we open? Up, down, left, or right? Well, again, this is negative 7 and negative 7. So the y is the same now, okay? The x's are changing, so that means I'm moving horizontally. So that means I'm opening horizontally, okay? So I know that. Now think about the vertex. The vertex is 4. The focus is 17/4. The focus is larger, right? It's to the right. So that means we're opening to the right. So immediately write down that p is greater than 0. Okay, so you remember that. If we're opening to the left, you got to remind yourself that p is going to be negative. If you're opening down, p is going to be negative. You've got to account for that, okay? Very important. So what I want to do now is think about my p. Let's just go ahead and get it. So it would be the distance between this and this. So again, don't worry about this. You're just subtracting 17/4 minus 4 16/4. So that's going to be 1/4. Okay, so your p value is positive 1/4. Again, notice how it doesn't work out to be this in this case. So don't grab that like we did when we had a vertex at 0, 0. That is a very, very common mistake when you get on these problems. So we have p equal to 1/4. So now, what's our equation? Well, we have that y minus k quantity squared is equal to, we've got this 4p times the quantity x minus h. P is a fourth. If I plugged in a fourth there, 4 times a fourth is 1. Get rid of that. If I plugged in 4, again, this is h, this is k, so h goes over here now. So this is 4, and this is negative 7, so minus the negative 7 is plus 7. And if you wanted to drop the parentheses, you can, and you could just add 4 to both sides and solve this for x. So x is equal to the quantity y plus 7 squared plus 4, okay? Now your directrix, let me erase this. Your directrix, how do we find that? Again, we know that this guy is now going to be a vertical line. So x equals something because it opens horizontally, opens to the right, okay? So we know that the distance between this and this is the same as the distance between the vertex and the directrix. Again, this was the distance of 1/4. We went to the right. So now we need to go to the left because again, if you think about this, this is opening to the right, okay? So your focus is here, your directrix needs to be over here. So you need to go this way now, okay? So I would subtract 1/4, this value here, away from 4. So what is 16/4 minus 1/4? That's 15/4, okay? So x equals 15/4 is going to be your directrix here. So I know these problems are quite challenging when you first see them. They can seem kind of overwhelming just finding the value of p, but once you get used to this, it becomes very, very easy to eyeball this and say, okay, I know it opens to the right. I know p is going to be, the distance between this and this. And then once I have that, I can find the directrix. I can find my equation by substituting in. It's really not that bad. Now, I want to leave you with this. This is something that might be in your textbook. It might not be in your textbook. I find it super helpful when I'm working these problems just as a reference. So if you open to the right, your focus is h plus p, comma k. Okay, so if you open to the right, your focus is h plus p, comma k. And we can go back up. We know p is a fourth, so the focus is what? It's h, which is 4, plus 1/4, which is 17/4, comma k, which is negative 7. Does that match that? Yes, it does. Okay, and I probably should have used a highlighter there because I kind of covered it up. So let me highlight that. But basically, you see what your focus is. It matches exactly that formula. Now, your directrix is x equals h minus p. So we saw that. H in this case was 4, and we subtracted away 1/4, and we got 15/4. Okay, so that's that. Your equation, we already know this. Now, when you go to opening to the left, you have to change what P is, okay? It's going to be negative. That's another common mistake, all right? It's going to be negative. So your focus is H minus P, comma K. Your directrix is now X equals H plus P. Okay, remember, you're going in the opposite direction. And this changes, right? You have a negative here because the P is negative. You've got to remember to change that to negative, okay? Now, when you go up or down, it's the same kind of scenarios. But now, your H is constant here. That's not going to change. But you get K plus P if you're going up, and then K minus P if you're going down. We saw this earlier. Your directrix, if you're going up, Y equals K minus P. If you're going down, Y equals K plus P. Your equations here are the same, except that, again, if you're opening down, if you're going down, then you get a negative here because the P is negative. In this lesson, we want to talk about conic sections. And here specifically, we want to focus on the ellipse. All right, in the last lesson, we talked about the parabola. And specifically, we learned a new geometric definition for a parabola. We learned that no matter where we were on our parabola, that given point, that given x comma y ordered pair, is the same distance away from a fixed point called the focus as it is from a fixed line called the directrix. Now, when we get into talking about an ellipse, we see the concept of a focus again, but now we're going to have two of them, so we're going to call it the foci. Okay, so that's for two. And basically, an ellipse is the set of all points in a plane, the sum of whose distances from two fixed points, these foci, is going to be constant. When we work with an ellipse, when we start looking at these equations, you're generally going to start out with ones that have a center at the origin. This is the easiest case scenario. And then you're going to look at shifting this for harder problems. So we're going to start out with x squared over 25 plus y squared over 9 equals 1. And what I'm going to do is I'm going to go immediately to the coordinate plane where I've already graphed this, and I'm just going to walk you through some of the terminology that you're going to see in this section. This is not something that's very difficult to kind of work with, but there's a lot of terms that you have to remember, so it's more of a kind of tough vocabulary lesson where you just have to memorize a lot of stuff. So the first thing is, let's write our equation again. We have x squared over 25 plus y squared over 9, and this equals 1. Okay, so the first thing I want to talk about would be this point here and this point here. So where did those guys come from? What do they mean? And basically, if you think about this, these are the x-intercepts, right? So in this case, because our center is at the origin, these are the x-intercepts. How do I get the x-intercepts? I plug in a 0 for y. So if y was 0, this whole thing would be gone. I would have x squared over 25 equals 1. Now, when you work with the standard form of an ellipse, you're always going to have 1 on the right side. So this denominator here, if I multiply both sides by it, it's always going to set up to x squared equals 25, okay? Now I solve this with the square root property by saying I have the positive square root of 25 and the negative square root of 25, so that's 5 and negative 5. So let me erase this real quick. I can just say, and I'll just write this real fast, so y squared over 9, I can just say that for my x-intercepts, that I basically take the square root of 25, which is 5, and then comma, y is 0. And then I take the negative square root of 25, which is negative 5, and then comma 0. Okay? So the quick way to do that is just to look at this number right here, this denominator, under your x squared term, and just say, what's the principal square root? What's the negative square root? So if y is 0, you've got the principal square root. If y is 0, you've got your negative square root. So that's how you can get that quickly. You can use a similar thought process to get your y-intercepts. So here and here. So now x is 0 in each case. Okay, x is 0 in each case. And now what's the principal and negative square root of 9? So 3 and negative 3. Okay, so 3 and negative 3. Okay, so now we have those values. We know where those points came from. Now, let's talk a little bit more about the terminology. Because this ellipse is what we say a horizontal ellipse, it's short and fat, right? So it's stretched more horizontally than it is vertically. What happens is we call this line segment from right here, from negative 5, 0 to 5, 0, the major axis, okay? And the endpoints of the major axis are known as the vertices. So I'm just going to say this is a V here for vertices, And then the shorter axis, okay, so from this guy right here, which is 0, 3, down to this guy right here, which is 0, -3, that line segment there, you can call that the minor axis, okay? And those endpoints are known as the covertices. So C and then V, okay, covertices. So again, a lot to remember, just something you want to take for your notes. So the longer one, that's the major axis. The shorter one, that's the minor axis. When we work with this guy generically, what's going to happen is we're going to label the distance from the center to the vertex, okay, this vertex over here. We'll call this distance A, okay? We'll call the distance from the center to one of the covertices here, we'll call that B, okay? So we can show mathematically, and I'm not going to go into this, that C squared, okay, and C is going to be the distance from this guy right here to one of your foci, okay, I'm going to call that C. C squared is equal to A squared minus B squared, okay? So what happens is I can call A 5, right? Because the distance from here to here is 5 units, right? If I go from here to here or from here to here, it's 5 units, right? So A squared I know is 25, and B squared, again, B is 3, this is 3 units, so B squared is 9. So 25 minus 9 is 16, so C squared is equal to 16. If I take the principal square root of this guy, because I'm thinking about a distance, it's going to be 4, okay? So the focus here would occur, let me just kind of erase this because everything's just getting kind of jammed up here. The focus would occur 4 units to the right of this guy and 4 units to the left of this guy. So your focus, or your foci in this case, because you have 2, you would have 4, 0, and then you would have negative 4, 0, okay? So that's where those 2 points came from. Now, your foci are always going to occur on the major axis, okay? Always going to occur on the major axis. So now we know where all these points came from. We know where these 2 came from, okay? Again, these are the vertices, or the endpoints for the major axis. We know where these 2 points came from. Again, these are the covertices, or the endpoints for the minor axis. And then these guys right here are the foci. Again, we know that C squared equals A squared minus B squared. Now, generically, let me give you a formula. So if we see X squared over A squared plus Y squared over B squared equals 1, and A is greater than B, this is going to be a horizontal ellipse, okay? Think about what we just looked at. Here, 25 is greater than 9, okay? Think about the fact that we took the principal and negative square root of this 9. Just think about the principal square root. The principal square root of this guy is bigger than the principal square root of this guy. So if we're thinking about from the center going this many units to the right, and from the center going this many units up, well, if this kind of square root gives me a distance, if this amount as a distance is greater than this amount as a distance, it's horizontal, because if this number is bigger, it's stretched further horizontally than it is vertically, okay? So in this particular case, your vertices are given as what? All I have to do is take the principal and negative square root of that guy. So I would say A, 0, and then negative A, 0, and I'm good to go. The covertices, all I have to do is take the principal and negative square root of that guy. So 0, B, and then 0, negative B. And then the foci, okay, remember it's C squared equals A squared minus B squared. And then what happens is once you find that value of C, you're going to say you have C, 0, and then negative C, 0, okay? So you can plug in and figure that out. So now let's talk about a vertical ellipse, because things are going to change. So most books are going to keep A as the larger number, okay? So A is greater than B. So they're going to switch this up and say, this is A squared and this is B squared now, okay? So things are going to change because in this particular case, the vertices, again, because this is larger, it's going to involve taking the principal and negative square root of this number, okay? So the vertices, I'm going to change this up, and now 0 here and 0 here, and I'm going to put A here and negative A here, okay? So it's just something you got to get used to. The covertices, now I'm going to erase this and this, and I'm going to say that I have B and negative B, 0 and 0. And for my foci, this is going to change, and I'm going to say 0 and 0, C and negative C. Let me make that better, okay? So again, it's always going to be the case that c squared equals a squared minus b squared. Make sure that you assign a properly. So a is going to be greater than b if you want to use these formulas in this setup. All right, so let's look at an example of a vertical ellipse. So we see x squared over 16 plus y squared over 36 equals 1. So this is larger than this. So that's how I know we have a vertical ellipse. Because when I take the square root of 36, it's 6. When I take the square root of 16, it's 4. So think about it. I'm traveling from the center, okay, from the center. I'm going to go up 6 units, okay, up 6 units. And I'm going to go down 6 units. I'm going to go down 6 units. From the center, I'm going to go to the right 4 units. And I'm going to go to the left 4 units. So this guy is stretched more vertically than it is horizontally. So that's why it's a vertical ellipse, okay? Now let's think about some points here, and we'll look at the graph in a minute. So the vertices, again, these are the endpoints for the major axis. Now your major axis is going to be involved on the y-axis, okay? And so what we're going to say is that it's going to be 0, comma, square root of this is 6, and then 0, comma, negative square root of that is negative 6, okay? So again, if I start at the center, I go 6 units up. Start at the center, I go 6 units down, okay? Then the covertices, again, now that's going to be on the x-axis, okay? So I'm going to have square root of this guy is 4, comma 0, and then the negative square root of that is negative 4, comma 0. Okay, so again, start at the origin, and you go 4 units to the right. Start at the origin, you go 4 units to the left. Then again, for your foci, you want a squared, and then you want b squared. Remember, c squared equals a squared minus b squared. Assign these appropriately to where a is greater than b if you want to use this formula. So I know that 36 minus 16 is 20. Okay, so I would have c squared equals 20, okay? Now, technically, c is a distance if we want to think about it this way. So if I take the square root, I really only want to do the principal square root. But to fill out this kind of information here, I want to do the principal and the negative square root just to make things faster. So I'm going to say that c is equal to plus or minus the square root of 20, okay, just to get these coordinates. So it's going to be 0, comma, whatever that is, and then 0, comma, whatever that is, okay? So this is going to be, if you simplify it, c equals plus or minus. This is 4 times 5. And 4 is a perfect square, so that's 2 times 2, so you can pull that out. So plus or minus 2 times square root of 5. So you have 2 times square root of 5 and negative 2 times square root of 5. Again, c is technically a distance, okay? But you're traveling from the center to 2 times square root of 5, right? You're going up. And then you're traveling from the center down by 2 times square root of 5. So that's how you get those coordinates. Okay, so let's copy this. And let me erase this. And I'll just go through and label some points real quick. So we have the vertices, again, 0, 6 and 0, negative 6. So you see 0, 6 is here and 0, negative 6 is here. So again, these are the vertices because this line that's purple here, this is your line segment that's the major axis, okay? From 0, 6 down to 0, negative 6. This is longer than this one, okay? So that's why this is the major axis. That's why these are the vertices. Then the covertices, I don't know if this is readable here. Let me just kind of erase this and I'll move this up. You got 4, 0 and negative 4, 0. So 4, 0 and negative 4, 0. Okay, so those are your covertices. Again, that's the label we give for the endpoints of the minor axis. Again, this one's shorter than this one. So let's get rid of that. We've already plotted that. And then your foci, again, these are always going to be on the major axis. 2 times square root of 5 is about 4.472. So you can just go from 0 up to about 4.5 and say that'll be your point. And then from 0 down to, again, negative 4.5. Okay, it's not going to be that, but I'm just giving you an approximation that you can look at on the graph. Okay, we're not going to be able to actually plot that using kind of a scale with integers. Okay, so we've got everything plotted. Once you've done that and you've labeled everything, you just sketch your curve, right? So you're done. And basically you want to, just to reiterate this, think about the center here as the midpoint between these two covertices, okay? And it's also the midpoint between these vertices. And it's also the midpoint between these two foci, okay? So if you're ever asked what's the center and you're given the vertices or the covertices, you can figure it out with the midpoint formula. Okay, so let's talk a little bit about shifting things around now. We're just going to look at an example. We have the quantity x minus 1 squared over 25 plus the quantity y plus 1 squared over 16 equals 1. Now, The first thing I'm going to tell you is just think about the formula I just worked out with you and then just shift things, okay? So how does this shift? Well, because everything's wrapped in parentheses here, you think about things as the opposite as you would, okay? So this is -1 with x, okay? With x, you're thinking horizontally. And again, because it's wrapped in parentheses, you think about the opposite effect. If it's -1, I want to think about it shifting to the right one. So I'm going to say this shifts right 1 unit, okay? Now, inside of parentheses here, we've got +1. And now we're thinking about y. Y is vertical, okay? So do the opposite of what you think. It's +1, so that's going to shift me down 1 unit, okay? So shifts down 1 unit, okay? So think about this just as you would if it was centered at the origin, okay? What would we do? Well, we know this is horizontal because this is larger than this, okay? So my formula is x squared over a squared plus y squared over b squared is equal to 1, okay? And I know that my vertices will occur where? Well, again, I'm just going to take the positive and negative square root of this guy. So it's a comma 0 and then negative a comma 0. Okay, well, in this case, this is 25. Square root of 25 is 5. So it's 5 and -5, okay? So we'll shift this stuff in a minute. This is not going to be the final thing. We'll shift it in a minute, just so you know. Then we have the covertices. Okay, so from our formula, again, we turn to this b squared, and we say it's 0 comma square root of this guy. Square root of 16 is 4. And then 0 comma negative square root of that is -4. Okay? And then for the foci, okay, let's put f here. We have what? Well, we think about the fact that we have a squared minus b squared. That's what's going to give us c squared. So c squared equals 25 minus 16 is 9. So again, for practical purposes, we know c is a distance, so technically c is 3. But we need -3 and +3. So just say that it's plus or minus the square root of 9. So we'll say that we need 3 comma 0 and we need -3 comma 0. Okay, so let's erase that and let's think about how we can shift things now. So 1 unit right, 1 unit down. So all the x coordinates, if I'm going 1 unit to the right, I just add 1. Okay, so that's all I need to do. So I'm going to erase this and put 6, erase this and put -4. I'm going to erase this and put 4. I'm going to erase this and put -2. I'm going to erase this and put 1. And I'm going to erase this and put 1. Okay, then I'm going to shift all the y coordinates down 1. Okay, so I'm just going to subtract 1 everywhere. So this is -1 and -1. And then this is -1 and -1. And then this is going to be 3, and this is going to be -5. Okay, so let's copy this. So I've got everything pasted here. Let me just go through the points. Again, this is how you would graph this guy. So your vertices, you've got 6 comma -1, so 6 comma -1. And then -4 comma -1, so -4 comma -1. And then for your covertices, you've got 1 comma 3, so 1 comma 3. Then you got 1 comma -5, so 1 comma -5. And then your foci, you've got 4 comma -1, and you've got -2 comma -1, okay? So your center is right here, and this is going to be at 1 comma -1, okay? So everything has just been shifted 1 unit to the right and 1 unit down. Okay, let's talk a little bit about something you might see. You may need to go from general form to standard form before you can graph something. So I'm not going to graph anything else. I think you get the idea of that. It's pretty simple. But I do want to cover how to go from general form to standard form. And I also want to cover how you can get the equation if you're just given some general information. How can you kind of go through the thought process? So with this guy, we've already seen this when we worked with circles a long time ago. You should know that a circle is a special case ellipse where your A and your B are basically the same value, okay? But essentially what you want to do here is just do completing the square twice. So group your x terms together, group your y terms together, okay? Create 2 perfect square trinomials, factor those into binomials squared, and then set up your little equation, okay? So what I'm going to do first is say that I have 36x squared minus 72x, okay? And plus, I'm going to do y squared plus 20y. And this will be equal to 8. I'm just adding 8 to both sides, okay? So I didn't do anything fancy. You need the variable that's raised to the second power, your squared term, to have a coefficient of 1. When you work with this with the quadratics, you generally will divide everything, right? If you're trying to solve a quadratic equation with completing the square. But here you can't really do that. So what we're going to do is we're going to factor, okay? So we're going to pull this 36 out. And what I'm going to have is x squared minus 2x. And I'm going to leave a little space here because I got to add something. And then plus, I don't have to do that here. So y squared plus 20y. I'm going to leave a little space because I got to add something. This equals 8. How do I complete the square? Again, look at the coefficient for the variable raised to the first power. Cut it in half and square it. Negative 2 times a half is negative 1. Squared is 1. So you add 1 and subtract 1. Here, half of 20 is 10. 10 squared is 100. So add 100. And if I can fit this in, subtract 100. Okay. So what do I do about this? Well, it's inside the parentheses. So to close this down, I've got to distribute the 36. So what this would look like, okay, is 36 times, I'm going to say x squared minus 2x plus 1. I'm going to distribute this to the negative 1, so minus 36. Then moving on, we'll put plus. There's nothing out here, so I can just say y squared plus 20y, and then plus 100. Again, I can just close this down because nothing's out here. Then minus 100 equals 8. So negative 36 minus 100 is negative 136. So let me scroll down a little bit. And we'll rewrite this and say we have 36 times the quantity x squared. Or actually, let me just go ahead and factor this. This is x minus 1 quantity squared. And then I'm going to skip this for now. I'll get to it in a second. I'm going to say plus, you've got y plus 10 quantity squared. And then negative 36, again, minus 100 is minus 136. This equals 8. And let me scroll down a little bit. So now, add this to both sides of the equation. Okay, so plus 136 plus 136. You're going to have 36 times the quantity x minus 1 squared. Plus, you're going to have y plus 10 quantity squared equals 8 plus 136 is 144. To finish this up, you want this right side to be 1. Okay, so whatever this is over here, just divide everything by that. Okay, that's all you need to do. And 36 over 144. 144 divided by 36 is 4. So just put a 4 down here. And then this will stay, and this just becomes 1. Okay, so that's your equation. The quantity x minus 1 squared over 4 plus the quantity y plus 10 squared over 144 equals 1. Okay, let's talk about one more type of problem that you might encounter. You might be told to get the equation given the vertices and the foci. Now, how could we do this? We want something like this, x minus h quantity squared over, and this guy would say it would be a squared plus y minus k quantity squared over b squared equals 1. Okay. How am I going to get the center, the h comma k? Well, again, if I think about the vertices here, you got 11 comma negative 8, and you got negative 9 comma negative 8. Well, here's 11. Okay, I'm just going to put this as 11. So 11 comma negative 8 would be something like right here. And then negative 9 comma negative 8 would be like right here. Okay, so we know that if these are the vertices, okay, we know that this is going to be a horizontal ellipse, okay? We know that because the vertices are the endpoints of the major axis, and the major axis here is running horizontally, okay? So additionally, we know that the midpoint, okay, of this line segment is the center. So if you wanted to kind of count this out and cut it in half, you could, but I mean, really the easy way is just to eyeball this and say, okay, well, 11 minus 9 is going to give me 2, and then 2 divided by 2 is 1. So it's 1 comma negative 8. That's going to be the center. So I can erase this and put a 1, and then I can erase this and go minus the negative 8 is plus 8. Now additionally, we need a squared and we need b squared. So how do we get that? Well, a is the distance from the center, which is 1 comma negative 8, okay? So the distance from the center to one of your vertices, okay? So you can go either direction. So it's what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So A is 10. And again, you can just kind of count this. You don't need a graph. So if A is 10, I know A squared is 100. And to get B squared, I use my little formula that C squared, okay, is equal to A squared, which is 100, minus B squared. Okay. So what's C squared? Again, C is the distance from the foci to the center. So just take either one of these. So I'm going to say from 9 to 1 is going to be 8 units. Because again, if I plotted 9 comma negative 8, That's going to be right there. Okay, so the distance from here to here, it's 1, 2, 3, 4, 5, 6, 7, 8, right? 8 units. So you can count it like that, or you can just eyeball it and do it. It's pretty easy. So we know if it's 8 and I square 8, I get 64. Okay, so this is 64. And you can easily see that this is going to be 36, right? So if you subtract 100 away from each side, this would be what? It would be negative 36 is equal to, let me make that better. You'd have your negative b squared, divide both sides by negative 1, and you'd have b squared equals 36, right? We don't need b, we just need b squared. So this is 36. And then we're done, right? We have our equation. And basically, it's the quantity x minus 1 squared over 100 plus the quantity y plus 8 squared over 36 equals 1. So we know that this guy is going to be a horizontal ellipse, and we know how to go through and get what's missing, which is the covertices. Okay, we can kind of label everything and then sketch a nice graph. In this lesson, we want to talk about conic sections. And here specifically, we want to focus on the hyperbola. All right, so now that we just got finished talking about graphing an ellipse and the properties of an ellipse, we move on to the hyperbola. So the hyperbola is going to be very similar in terms of its equation, but very different in terms of its shape and how we go about graphing it. So the hyperbola is the set of all points in a plane such that the absolute value of the difference of the distances from two fixed points is constant. Again, these two fixed points are called the foci of the hyperbola. Now, when we start looking at the equation of a hyperbola, again, it's going to look very similar to the equation for an ellipse. So this guy is centered at the origin, and we're going to find out why in a minute, but it's going to open to the right and to the left. So we're going to have one what we call branch opening to the right and one branch that opens to the left. So just to show you a little preview of this, we're going to graph this in a minute, but one branch opens to the right and the other opens to the left. So let's talk a little bit about why that happens. And to do that, I want to just stop and talk about an ellipse for a moment. So we know if we saw something like x squared over 9 plus y squared over 16 equals 1, this is an ellipse, okay? So the plus here gives me an ellipse. The minus here is what gives me a hyperbola, okay? So why are these two going to be such a different shape? We saw the shape of the hyperbola. If we look at the ellipse, it's an oval shape. So what's creating the disparity between the two shapes? Well, it's that minus sign. X squared over 9 plus y squared over 16 equals 1. Forget about the formulas and all that stuff. I just want you to think back to x and y intercepts. Okay, this is how this is going to make sense. How do we get this point, this point, this point, and this point? Let's think about this. If I plug in a 0 for y, I'm getting my x-intercepts. Plug in a 0 for y, this is gone. So you have x squared over 9 is equal to 1. Okay, multiply both sides by 9. I've got x squared is equal to 9, which gives me a solution of x is equal to 3. And then also x is equal to negative 3. So you could say x equals plus or minus 3 if you want. Okay, so that's where this came from because, again, y is 0. So we would say 3 comma 0 there. That's where this came from. Again, y is 0, so negative 3 comma 0. Okay, so that's where those 2 points came from. Now, additionally, we're going to have points here and here. So where do those come from? Again, think about plugging in a 0 for x to get your y-intercepts. So here you'd have y squared over 16 equals 1. And again, y squared equals 16. If I multiply both sides by 16, and y is going to equal plus or minus 4. Okay, so that's how I get 0 comma 4 and 0 comma negative 4. And we already know about the equation of an ellipse, so on and so forth. I just want to show you that you end up with these kind of intercepts in this case. So you're able to sketch this graph through these 4 points. So that's what's creating this shape. Now, when we go back to the hyperbola, you're not going to get these 4 points to connect, okay? And the reason is because of this minus sign. Let's think about this for a second. If I have x squared over 9 minus y squared over 16 equals 1, plug in a 0 for y, it's a similar thought process. X squared over 9 equals 1. X is going to equal plus or minus 3. Okay, so that means that 3 comma 0 is on the graph, and negative 3 comma 0 is on the graph. We can see those points right here, right? Here's 3 comma 0, here's negative 3 comma 0. Okay, so from the center, I'm going 3 units to the right, I'm going 3 units to the left. We're going to find out in a minute that that distance, again, is called A. Okay, in this particular case, we know that when we work with these equations, we have these generic forms. So right now, I'm just going to write that A is equal to 3. Okay, we'll revisit that in a moment. How do we get the y-intercepts here? I'm just going to erase that. Well, I could plug in a 0 for x. This would go away. you'd have negative y squared over 16 is equal to 1. Multiply both sides by negative 16 to clear the denominator and the negative. You're going to have y squared is equal to negative 16, okay, which doesn't have a real solution, right? If I took the square root of this side, I'd have y. If I go plus or minus the square root of this side, okay, you're going to have a complex solution there, or a non-real complex solution to be specific, right? One with the imaginary unit I. We won't have this on our coordinate plane, so we won't have any y-intercepts. So that's why, if you look at the graph, you don't see any points where this guy is going to intersect the y-axis. That's what's creating that, and that's why we have a shape that is opening to the right and opening to the left, right? You don't have anything on the y-axis like you had with your ellipse, right? You have points up here that you can connect, so that's why there's a drastically different shape between this guy and this guy, okay? So let's talk a little bit more about our hyperbola in general. So I'm just going to go up here to kind of the equations you'd see in your book and run through them real quick. So this is the one we're working with, where we have the minus in front of the y squared over b squared. The other one is where you have the minus in front of the x squared over b squared. Whatever has the minus in front of it, again, because of that minus sign, in this case, you wouldn't have x-intercepts, so this guy's going to open up and down, okay? And we'll see an example of that later on. In this case, we already know we won't have y-intercepts, so it's going to open to the right and to the left, okay? So that's what's causing that. Now your vertices, okay, your vertices are going to be at a comma 0 and negative a comma 0. And from the center to one of your vertices is going to be a distance of a. So that's why I wrote down a equals 3. Okay, so we know that later on when we come back. Now, b is going to have a purpose here, and I'll talk about that in a moment. But your foci are at c comma 0 and then negative c comma 0. And now your formula to get c is a bit different. Before, it was c squared equals a squared minus b squared. Okay, remember that. Now, c squared is going to be a squared plus b squared. Really easy to remember because it matches the letters and the exact format of the Pythagorean formula. Okay. Now, similarly, when we work with the hyperbola that's opening up and down, everything is just kind of swapped because we have something that's opening up and down. So now the vertices are going to be 0, a and 0, negative a. So they'll be on the y-axis in this case. And your foci will be on the y-axis as well now. So 0, c and 0, negative c. Notice that a and b have been swapped. Okay, so that's the most difficult thing with these formulas. They're swapping around letters, and that's where people get confused. And so as we move through this lesson, I'm going to show you not to use this formula. You can just come up with your own. Okay, so let's go back. And let's talk about how we can get the rest of this stuff that's graphed here. So we know a equals 3. I can erase that here. I've already explained why. Basically, you want to think about, again, our equation is x squared over 9 plus y squared over 16 equals 1. And this is minus, not plus. Okay, so with this guy, I have these kind of 4 points that make up a rectangle. Where does that come from? Well, this is called the fundamental rectangle. So let me put fundamental rectangle like that. And basically what you do is you think about these as 4 points as the 4 corners or the 4 endpoints of the rectangle. And normally, depending on your equation, you're going to get something like a comma b, or you might get b comma a, depending again on the equation in your book. And then you go through the possibilities of that. Well, I'm going to tell you to not do that, okay? Let's not use those because they get confusing. Remember, this is an x coordinate and this is a y coordinate, okay? So for the x coordinate, go underneath x squared and look at your number here, okay? Take the square root, that's what you want, okay? Remember, go underneath x squared for x. That's all you got to remember. Go underneath y squared for y, take the square root of that number, it's 4. Then you're going to go through all the positive and negative combinations of that. So you've got 3 comma 4, you would have negative 3 comma 4. You would have 3 comma negative 4, and then you would have negative 3 comma negative 4. So those 4 guys there are going to give you your 4 endpoints. So your 3 comma 4, your 3 comma negative 4, your negative 3 comma 4, and your negative 3 comma negative 4. Okay, you can think about this guy, again, this is b squared. So the distance of b, you're going a distance of a units horizontally and a distance of b units vertically. So if I go 3 units to the right and 4 units up, if I go 3 units to the right and 4 units down. If I go 3 units to the left and 4 units up, and then 3 units left and 4 units down. So that's another way you can think about that. We know that c squared is equal to a squared plus b squared, okay? In this case, you don't have to remember what a is and what b is because you could just add these two. So 9 plus 16 is 25, so c squared would be 25. And just take the principal square root here, that would be 5. Okay, so c is 5. Remember, c is the distance from the center to the foci, so it's 5 units. 5 units to the right and 5 units to the left. And your foci are always going to be along the axis where you're opening, right? So if I'm opening along the x-axis, okay, I'm going to the right and to the left, well, my foci are going to be on that axis, okay? So it might be shifted if you get a different type of equation, but in this case, it's going to be on the x-axis because we're centered at the origin. So the foci would be 5, 0, and then negative 5, 0. Okay, so pretty easy to remember that as well. Now, the last thing I want to talk about is where we get these lines from. Basically, when you draw the fundamental rectangle, you can extend from the diagonals these lines. Okay, these are your asymptotes. And basically, when you sketch the graph of these branches, as we say, right, each side is a different branch, you're going to sketch them to where they approach the asymptote, okay? They go through the vertex and then approach the asymptote, okay? So that's how you're going to do that. Now, another way to get these lines or these asymptotes, you have this, let me just erase this because my screen's going to get too busy. You have this formula that says y is equal to plus or minus, I'm just going to say rise over run, okay? And I'm going to tell you why in a minute, times x, okay? So why did I put rise over run? Well, because again, they use that b over a or a over b and it keeps switching and people get confused. So if you write rise over run here, you remember that rise is associated with the vertical movement or the y-axis, okay? How much am I going up and down? So y, I look at y squared, I look underneath, I get the square root of that number. So square root of 16 is 4. So you're going to put 4 there, okay? For the run, I think about x squared. Under x squared, I have 9. Square root of that is 3. Okay, so that's all you need to do. So these would be the two equations for these asymptotes, so you can get it that way as well. Basically, you would have y equals 4/3 x, start at the origin, go up 1, 2, 3, 4, to the right 1, 2, 3, there's a point. Then for the other one, y equals negative 4/3 x, start at the origin, go down 1, 2, 3, 4, to the right 1, 2, 3, there's a point, okay? So that's basically it when you talk about sketching the graph of a hyperbola. They generally want you to find the vertices, the foci, okay, the fundamental rectangle, the asymptotes, and then sketch the graph. Okay, there's not much more to it. It can get shifted, like we're going to see in this example here, and then it gets a little bit more complex. So this one is going to be double complex because I gave it to you in general form, so you have to complete the square first. So you might get examples like this as well. And so let's blow through this real quick. We already know how to do this. We're going to group our x terms together. So negative 16x squared. And then I'm going to go plus my 32x and plus, well, let me not do that yet. So let me just kind of close this down. Then plus, we'll go 9y squared plus 18y. And then I'm going to add this 151 to each side so that it cancels over here and goes over here. So equals 151, okay? And basically, I'm doing this because I want to create a perfect square trinomial here, okay, here, and here, okay? So I'm going to add and subtract the same number inside of the parentheses. But before I can do that, remember the coefficient for your squared variable needs to be a 1. We're not going to divide anything here. We're going to factor. Okay, so I'm going to pull out a negative 16 here. I'm going to pull out a 9 here. So negative 16 times the quantity x squared. In this case, it would be minus 2x. Okay, and I'm going to leave a little space there. And then plus, I got to pull out a 9 here, times y squared. This would be plus 2y. We'll leave a little space there. And then this equals 151. Okay, so what goes here and here? Well, all you need to do is cut this coefficient here, the one on the variable raised to the first power, in half, meaning you multiply it by a half and then square it. If you have negative 2 times a half, you get negative 1. Negative 1 squared is 1. Same thing for 2. If you cut it in half, you get 1. 1 squared is 1. Okay, so in each case, you're going to end up with 1. So you add 1 and subtract 1. Add 1 and subtract 1, okay? But remember, you want only this part here because that's the perfect square trinomial. You want only this part here. But to do that and kind of get this part outside of the parentheses, you've got to distribute the negative 16 and you've got to distribute the 9, okay? So that's very important. So what I'm going to do is say that I have negative 16 times the quantity. I'm going to close this down and factor it. So it's going to be x minus 1 quantity squared. And then it's going to be negative 16 times negative 1, which is plus 16. Okay. And then you're going to have plus your 9 times, I'm going to close this down and factor. So y, and it's going to be plus 1 quantity squared. And then 9 times negative 1 would be minus 9. This equals 151. Okay. So from here, it's kind of a piece of cake. Basically, what you want to do is say 16 minus 9 is going to give you 7. So let's just erase this and put a 7 here. And if I subtract 7 away from each side of the equation, this is going to cancel. Okay, and then over here, this would become 144. Okay, so I can say I have negative 16 times the quantity x minus 1 squared plus 9 times the quantity y plus 1 squared equals 144. Okay, so to finish this up, I want this to be a 1. So divide everything by 144 and you'll be done. Okay, let's scroll down a little bit more. So in this case, 144 divided by 16 is 9. And you got the negative there. So let's make this a negative out in front and make this a 9 down here. And then 144 divided by 9 is 16. So let's make this a 16 down here. And we know this is a 1. Now, you typically don't want to write it like this. Whatever you have your minus out in front of, you want to put that in the middle. So you would want to say that this is the quantity y plus 1 squared over 16. And then minus, you have your quantity x minus 1 squared, and then over 9, and this equals 1. Okay, so let's go ahead and copy this. All right, let's go ahead and paste this in here. And we're just going to walk through how we get this. The way I like to do these is I like to think about my formula, okay, my generic formula without the a and the b involved, and then I shift them based on what the new center is. Okay, so I pretend like the center is here, and then I shift it here. Okay, so I'm going to shift all the points. So I just want to think about the fact that this guy is going to open up and down. We can see that clearly, but if we didn't know that, if we didn't have a graph in front of us, you have the minus here, and it's in front of where you have the x variable involved. So again, that's how we know that it's going to open up and down. Okay, if the minus was in front of where you had the y involved, you would open to the right and to the left. Now, let's talk about how you get the vertices. Okay, we know that with our other formula, if we had something like y squared over, let's say, a squared, just for right now, then minus x squared over b squared, okay, and this equals 1. Well, this guy right here, again, I would take the square root of that, whatever that number is, okay, and I would say that my y-intercepts would be at 0, a, okay, and then 0, negative a. Okay, we talked about that already. That's how you find your vertices in this case. Well, here, everything is shifted 1 unit down because of the plus 1, and 1 unit to the right because of the minus 1. So if I started with this guy right here and said, okay, my vertices would be at 0, 4 and 0, negative 4. Well, okay, I've got to shift it 1 unit down. So this would be a 3, okay, and this would be a negative 5. And then I would go 1 unit to the right. So this would be a 1 and this would be a 1. Okay, so I'm looking for 1, 3. So 1, 3. So that's right there. Let me choose a different color. So this is right there. And then 1, negative 5. So 1, negative 5 is going to be right there. Okay, so that's where those two vertices come from. Of course, the center comes from this right here. So it's minus whatever this is. Okay, so it's 1. This is not in that format, so you have to change it, right? If it's a plus 1, you think about it as minus a negative 1. Okay, so it's going to be at 1, negative 1. So 1, negative 1. So right there, that's your center. Now, let's talk a little bit about your foci. Okay, your foci. So we know that c squared is equal to a squared plus b squared. But again, everything is shifted, okay? So first you go again with the 16 plus 9, that's 25, okay? So you have c squared equals 25, so c is 5. So if this was centered at the origin, it would be at 0, 5 and 0, negative 5. But again, everything is shifted 1 unit to the right, so I'd put this at a 1 and a 1. And everything is shifted 1 unit down, so this would be a 4, and this would be a negative 6. So you'd have 1, 4, so 1, 4, so that's right there. And then 1, negative 6, so 1, negative 6, so that's right there. So that's where those two foci come from. Okay, let's talk about the fundamental rectangle now. Okay, so where do these endpoints come from? Again, I think about x, y. This is how I always write it. Okay, so where does x come from? Where does y come from? Okay, well, x comes from what's underneath the variable x I know in this case it doesn't look like just x squared, but just go to where x is, go underneath, take the square root. So the square root of that is 3, okay? Then go underneath where y is, take the square root of that, that's 4. So you got 3 comma 4. Now, things have been shifted because the center's moved, okay? So you've got to account for that. So now what I'm going to say is that, let's just kind of go through the possibilities of this and we'll adjust. So it would be 3 comma 4, it would be negative 3 comma 4, it would be 3 comma negative 4, and then it would be negative 3 comma negative 4. Well, everything is shifted 1 unit to the right. So this one and this one would be 4. This one and this one would be negative 2, okay? Then also, everything has shifted 1 unit down. So this one and this one would be 3. And this one and this one would be negative 5. Okay, so that's how I do it personally. You may have a different formula that works better, but that works for me. So you can see the endpoints of this guy are going to be 4 comma 3, so right there. And then you've got 4 comma negative 5, so right there. And then you've got negative 2 comma 3, so right there. And then negative 2 comma negative 5. Again, all you're really doing is saying from the center, okay, from the center, wherever that is, I'm going 3 units to the right and 4 units up. So from the center, if I go 3 units to the right, I go 1, 2, 3, and 4 units up, I go there. From the center, if I go 3 units to the left and 4 units up, I go there. From the center, if I go 3 units to the left and 4 units down, I go there. From the center, if I go 3 units to the right and 4 units down, I go there. So it's the same thought process. You just have to shift things because the center has moved. Now, you have your fundamental rectangle, so you can sketch the graph of the asymptotes. And at this point, if you're just told that you want to graph this guy, you're done. Okay, you don't need to go through and get the equation of these asymptotes. But if you do need that equation, okay, it is a little bit more work. Because now you're not going to be able to just say that y is equal to plus or minus, in this case, it would be 4/3 times x, because I took the 4 from here for the rise, the 3 from here for the run, okay? You can't just do that because the center's not at the origin, okay? So you have to take a point on this line and you have to use point slope form, okay? You know the slope, right? It's still going to be 4/3 and then negative 4/3, but you don't exactly have the equation. So you have to go y minus y sub 1, and I'm going to take the y coordinate from the center, which is negative 1. So I'm going to say y minus y sub 1, y minus negative 1 is y plus 1, is equal to, I'm going to go with 4/3 first, times the quantity. You're going to have x minus, again from the center, the x coordinate is 1, so x minus 1. And so you would go through and figure this out. So you'd have y is equal to, subtract 1 away from each side, you'd have 4/3 x minus 4/3. And then I can go ahead and say this is minus 3/3. So this is 4/3 x minus 7/3. So that would be one equation, okay? For the other one, you would need to work with negative 4/3, okay? So y minus y sub 1, in this case, y sub 1 is negative 1, so y plus 1, equals negative 4/3 times the quantity x minus, in this case, our x value is 1, so we're going to say x minus 1. So what you'll have here is y is equal to, I'm going to subtract 1 away from each side, so negative 4/3 x, negative 4/3 times negative 1 is plus 4/3. Again, I subtracted 1 away from each side, so minus 3/3. So this would end up being 1/3 here. Okay, so this is 1/3. Okay, so I know this is long and tedious, but again, this is stuff that you do have to know. So let's kind of move this up here, and you can check this real quick. I know that the y-intercept of 1/3 is a little bit difficult to find, but let's just go ahead and say that that's right here, okay? And then the slope is negative 4/3. So if I go down 4, if I go down 1, 2, 3, 4, and I go to the right 3, so 1, 2, 3, you see that should be about right there. Again, it's not perfect because we're not working with integers, but it's very, very close, okay? And then if you look at this one right here, 4/3 x minus 7/3, again, now I'm going with the positive slope. So if I look at negative 7/3, let's say that's about right there. So if I start here and go up 4, so 1, 2, 3, 4, and then go to the right 1, 2, 3, again, I'd be about right there. Okay, it's not perfect, but when you work with non-integer values, you're always going to be somewhat off. Okay, so that's where everything comes from in this particular case. If you're asked for your asymptotes, you know how to find them. If you're asked for your fundamental rectangle, you know how to get it. Basically, you just use the technique that we talked about. You just shift things based on where your center has moved. Okay, let's talk about one final topic. This is something that you will get, and it is a bit frustrating. So let's say you're given the vertices and the foci only, and they say come up with the equation. Okay, so it's a lot easier than you think. The vertices you're given, remember, from the center of the hyperbola to one of the vertices is the same distance from the center to the other vertex. So if I took these two and thought about the midpoint of this line segment, okay, that would be the center, okay, of this hyperbola. So I have -5 and -5. That doesn't change. So if the x value is not changing, okay, that tells me this guy is opening up and down, okay? So what I would do is say that the center is going to be -5 plus -5 is -10 divided by 2 and back to -5, right? That doesn't change. And then -1 plus -9 is -10 divided by 2, I get -5. So my center is at -5, -5. Okay, so what does that tell me? That I'm looking at something like this. I'm looking at something like y plus 5, right? Because it's always minus whatever it is. In this case, it's -5. Quantity squared over, let's just say a squared for now. Then minus, you would have x, again, plus 5, because it's -5. Quantity squared, let's say this is over b squared. This equals 1. So we need to find a squared, and we need to find b squared. So what is a? A is the distance from the center to one of your vertices. Okay, well, if I went from -5, -5 to -5, -1, how far did I travel? Well, this, -5 and -5, that's the same, right? Because I'm traveling vertically. I'm going up. So all I need to compare is -5 to -1. How far did I travel? Well, 4 units, right? So that tells me a is 4, so a squared is 16. Okay, so I've got that part. Now I need b squared, okay? And where this is going to come from is from that formula that a squared plus b squared equals c squared, okay? And in this particular case, you've got your foci that occur at -5, -5 plus square root of 65, and -5, -5 minus the square root of 65. Okay, you only need one of these. But basically, c is the distance from the center, which again occurs at -5, -5, to one of these guys. Let's just say the -5, -5 plus square root of 65. Okay, well, we know this x-coordinate is the same in each case, so I'm just comparing the y-coordinates. So how far did I move in this case up, right? So I went, this is -5 and this is -5, so just erase those. You just have the square root of 65 left. So I'm traveling from the center up by the square root of 65 units. So that's going to be my c, okay? So c squared would be 65. So a squared is 16 and c squared is 65. Let me make that better. So what is b squared? Well, if I subtract 16 away from each side of this equation, I would see that b squared is equal to 49. And so that's all I need. I don't need to know that b is 7, right? I could take the square root, but I need b squared, so this is 49. So it seems a little bit harder than it is. It doesn't take that long, but you do have to kind of know what is a, that's the distance from the center to one of your vertices. What is c, that's the distance from your center to one of your foci. And then for getting b, you need to go through this formula and crank that out. So we get the quantity y plus 5 squared over 16 minus the quantity x plus 5 squared over 49 is equal to 1. In this lesson, we want to talk about solving nonlinear systems of equations. All right, so when you get to this section, basically what you're looking at are systems where at least one equation is nonlinear. Now, solving these, it's not a hard thing to do when you get to this section, but it is tedious. And there's not one general approach. So every problem you see has a different approach or different strategy to it. So I'm going to do 5 examples that cover basically all the different types of problems that you're going to see. You might get other ones, but it's very easy to take one of these examples and apply it to yours. All right, so let's go ahead and get started. The first one's a very easy example. We have one that's not linear and one that is. So we have 2x squared plus 2y squared minus 21x minus 6y plus 44 equals 0, and x minus 2y equals -4. So the strategy here is going to be to solve this linear equation for one of the variables and then plug in to this kind of top equation that's not linear. Now, when you do this, you might get extraneous solutions. I'm not going to be checking things because this video is already going to be really long because it's tedious. But I advise you to check your solutions because when you solve these, you can often get extraneous solutions. So there are solutions that won't work in the original problem. All right, so let's go ahead and get started. I'm going to solve this bottom equation for x. So we'd have x is equal to, if I add 2y to both sides of the equation, I would have 2y minus 4. So once I have that, I know x is equal to this. So I can plug this in everywhere there's an x in this top equation. Okay, so I can plug it in there and also there. Okay, so that's what I'm going to do. That's going to give me an equation with just y, right? And then I can solve. So I would have 2 times, I've got to use parentheses here because this guy, I'm plugging in for that, and it's squared. So 2y minus 4, that quantity is squared. And then plus, you've got 2y squared minus 21 times, again, use parentheses when you're plugging in. So we've got 2y minus 4, and then minus 6y plus 44 equals 0. Okay, so the common thing there where you'd make a mistake is to not use parentheses. So you got to make sure you do that. All right, so once we have it set up, it's very straightforward. You just have to do a lot of simplifying, which can take some time. This guy right here, we know how to expand this. Again, this is squared. So I would square the first term. 2y squared is 4y squared. Then you have minus 2 times this guy times this guy. So 2 times 2 is 4, 4 times 4 is 16, then times y is 16y, okay? And then you'd have the last guy, the 4 squared, so plus 16. Now, this guy is being multiplied by 2. So let me just wrap this like this. We'll just move on. We'll clear that in a moment. So we have plus this 2y squared. I'm going to distribute this to each. So I'm going to distribute that to each term there. So negative 21 times 2y is going to give me negative 42y. And then negative 21 times negative 4 is going to give me positive 84. Okay. Then I have minus 6y plus 44, and this equals 0. All right, so I know I need to distribute here. So let me just kind of do that. 2 times 4y squared would be 8y squared. 2 times negative 16y would be minus 32y. And then 2 times 16 would be plus 32. So let me just erase this, and I'll just kind of drag this up. And I'll just slide this down a bit so we have more room to work. And let's think about what our like terms are going to be. So we see that we have this guy and this guy, right? Nothing else that's squared. So 8y squared and 2y squared would give me 10y squared. So 10y squared. Okay, so what else? Well, we have this guy right here, this guy right here, and this guy right here. Let me unhighlight these so we can be clear on what we're working with. So we have negative 32y, minus 42y, and negative 6y. Okay, so negative 32 minus 42 is negative 74, and then minus another 6 would be negative 80. So this would give me minus 80y. Okay, so let me unhighlight those now. And then lastly, we have the constants. So you've got 32, 84, and 44. Okay, so 32 plus 84 is 116. Then if I add 44, I get 160. So plus 160, and this equals 0. All right, let's scroll down and get some room. We'll come back up in a minute. So what I notice immediately is that this guy right here, this guy right here, and this guy right here, they all have a 0 at the end of the number. So that tells me everything's divisible by 10. So I can make this simpler by just dividing everything in that equation by 10. So this would be y squared. This would be minus 8y. This would be plus 16. And of course, this would still equal 0 because 0 divided by 10 is 0. So from here, now it's very easy to solve. I can factor this. So y and y. And we know that this is going to be what? It's a perfect square trinomial, right? Because if I factor this, it becomes a binomial squared. It becomes y minus 4 quantity squared. Okay, so you can write it out the long way like this, or again, you can put y minus 4 quantity squared. So this guy only has one solution. It's y equals 4. All right, so let me erase everything. I'm just going to write y equals 4 here for your notes. And I'm going to erase everything. So now that we know that y equals 4, I can plug in a 4 for y either in the first equation or the second equation. I'm going to pick the second equation because it's simpler. So plug in there and you would say x minus 2 times, just plug in a 4 for y, equals negative 4. Of course, 2 times 4 is 8, so you can just erase that and put 8. Add 8 to both sides of the equation. You find that x is equal to 4 as well. So the ordered pair solution here would be 4, comma 4, right? An x value of 4 and a y value of 4. Now, I just want to say this one more time. When you're solving these, you have to make sure that you stop and check your answer in both equations of the system to make sure it works. I've already done that, so I'm going to be skipping that so I can make this video a little bit shorter. All right, so the next system is very easy to solve. It's when you get two parabolas, okay? So you'll notice that you have negative 2x squared plus 14x plus y minus 14 equals 0, 7x squared minus 49x plus y plus 76 equals 0. You just have y to the first power and y to the first power. No other y's, okay? But you have your x squared and your x to the first power. So if you wanted to, you could rewrite these and solve them for y. And in each case, you're going to have y equals ax squared plus bx plus c, okay? So let's go ahead and solve each one for y real quick, and I'll explain how we can quickly solve this. So what I'm going to do is just move everything to the other side since y is already over here. So I'll say this is y equals 2x squared minus 14x and then plus 14. So again, kept this on this side, moved everything to the other side. So all I'm doing is just changing the signs. Okay, that's all I did. Then for this one, I'm going to do the same thing. So y is equal to, and then I'm just going to move everything to the other side. So I'll just be changing the signs. So I'll have negative 7x squared plus 49x and then minus 76. So once you've written it in this format, remember, if I'm solving a system, I want to find the points of intersection. So where are these guys going to be equal or the same? Well, where they're going to be equal, the y values would be the same. So if this guy represents y and this guy represents y, well, I can set those two equal to each other and solve for the x value that makes that happen. Okay, so what I'm going to do is say that 2x squared minus 14x plus 14, again, this represents y here, is equal to the y from here, which would be negative 7x squared plus 49x minus 76. So when you get these, they're very, very easy to set up. Just solve each one for y and then equate the two, okay? So we'll say that we have what? If I add 7x squared to both sides, I'm going to have 9x squared right here. And let's go ahead and just cancel that out. I'm going to subtract 49x away from each side of the equation. So let's cancel that out there. And if I did negative 14x minus 49x, I would get negative 63x. So let's put minus 63x here. And then lastly, let's go ahead and add 76 to both sides of the equation. And I just want to strike that out real quick. So 14 plus 76 is going to give me 90. And of course, on this side, everything's canceled, so it's a 0. Okay, so this is equal to 0. So now we just have a quadratic equation that we've been solving forever. We know that immediately everything here is divisible by 9, right? So I can divide everything by 9 and get x squared minus 7x plus 10 equals 0. This is something I can solve with factoring again. Very, very easy. Let's go ahead and set this up. X here and x here. And to think about the factors, what adds up to negative 7 and multiplies to be 10, right? What two integers? Well, we know we could do negative 2 and negative 5, right? So negative 2 and negative 5. So if I set each one of these factors equal to 0 and solved, I would get x equals 2 and then x equals 5. So x equals 2 and then also 5. Okay, so let's erase everything. So at this point, what I want to do is plug in a 2 for x, see what y is equal to, and then plug in a 5 for x, see what y is going to be equal to, okay? So if I start out with 2, let's just use the top equation. So negative 2 times, you'd have 2 squared, so let's just go ahead and say this is 4. And then plus 14 times 2 is 28. And then plus y minus 14 equals 0. So we know negative 2 times 4 is negative 8. Okay, so negative 8. And you might as well just say negative 8 plus 28 is 20. Okay, and then 20 minus 14 is 6. So let's just say at this point we have y plus 6 equals 0. Let's subtract 6 away from each side of the equation and say y is equal to negative 6. So if x is 2, y is negative 6. And again, you can check that in each equation and make sure it is true. Okay, so I've already checked it, so I know that 2 comma negative 6 is a solution. So let's erase this and work with 5 now. So if I do negative 2 times 5 squared is 25, plus 14 times 5, which is 70, plus y minus 14 equals 0. Well, I know this is negative 50, right? Negative 2 times 25 is negative 50. Negative 50 plus 70 is 20. And then 20 minus 14 is again 6. So we know that we're going to end up with y is equal to negative 6 again. So the other solution would be 5, comma, negative 6. So we have an ordered pair, 2, comma, negative 6 that works. And again, it works in each. You can stop the video and check. And then 5, comma, negative 6, that works as well. Again, you can pause the video and check that. All right, the next type of example is one that is best solved using elimination. So we have 3x squared plus y squared equals 3, and 4x squared plus 5y squared equals 26. All right, so what I'm going to do is eliminate the y variable. It's pretty easy to do because I can just multiply equation 1 by negative 5. So I would have what? Negative 15x squared minus 5y squared equals negative 15. Again, I just multiplied everything there by negative 5. So then this second equation stays the same. Let me just copy it real quick. And we're going to add these two together. And what will we get? Negative 15x squared plus 4x squared would be negative 11x squared. This would be gone. And negative 15 plus 26 is going to be 11. So let me erase this. And let's drag this up here. And let me divide both sides by negative 11. And we'll find that x squared is equal to negative 1. Okay. Well, if we want to get x by itself, we got to take the square root of each side. So I take the square root of this side, and I go plus or minus the square root of this side. We know the square root of negative 1, if we want to use the complex number system, is I, right, the imaginary unit. So I can just go ahead and say that x is equal to plus or minus I. Okay, so plus or minus the imaginary unit. So you can really say that you have x is equal to I, and then also negative I. Okay, so we got to plug each of these in. So if I plug in I, remember, I squared by definition is negative 1. So 3 times negative 1, because that's all I squared is, plus y squared is equal to 3. Well, this is negative 3 plus y squared equals 3. Add 3 to both sides, and we're going to get that y squared is equal to 6. Okay, so now if I want to get y by itself, I got to take the square root of each side. So square root of this side, and then plus or minus square root of this side. So y is equal to plus or minus the square root of 6. Okay, and I can't make that any simpler. So if x is I, the imaginary unit, then y is the square root of 6. And then also, if it's I, it's the negative square root of 6. So those are two different solutions. Again, if it's I, you get the square root of 6, or if it's I, you also get the negative square root of 6. All right, let's think about this other possibility here, where x is negative I. Now, we see that if we plug this into this equation here, just think about the fact that, okay, I have negative I being squared, but it's going to give me the same result. If I think about negative I as negative 1 times I, and this is squared, well, this is what? This is negative 1 squared times I squared, which is 1 times negative 1, which is negative 1. So it's still going to give me negative 3 here. So I'm going to go through and get the same result. Okay. So really, I can just say that I would have negative I, comma, square root of 6. And then also negative I, comma, negative square root of 6. So there's your 4 solutions for this guy. Again, for this one, you want to use elimination. And again, I've already checked my answers, so I know they work. All right, so the next one we're going to look at, we want to do elimination and substitution. So these generally take a little bit of time. So I have this x squared plus 8x minus y squared plus 10y minus 33 equals 0, and x squared plus 8x minus 5y squared plus 42y minus 97 equals 0. Notice how these are the same, okay? So what I can do here is start by multiplying this bottom equation by negative 1. So what I'd have is, let me copy the top one. So x squared plus 8x minus y squared plus 10y minus 33 equals 0. For this one, if I multiplied by negative 1, I'd have negative x squared. And then we'd have minus 8x plus 5y squared. And then you'd have minus 42y plus 97 equals 0. If I add the left sides together, and I set this equal to the sum of the right sides, which again would just be 0 in this case, well, this is going to cancel, okay? So what I have is negative y squared plus 5y squared, which is 4y squared. 10y minus 42y would be minus 32y. And then 33 plus 97 is 64. So plus 64 here. Okay, so again, we notice that, and let me just erase this, and let me drag this up. So again, as I was saying, we notice that everything here is divisible by 4. So just divide through and get rid of it. So if I divided this by 4, I'd have y squared. Divide this by 4, I'd have negative 8y. And let me make that a little bit better. So minus 8y. Divide this by 4, you'd have 16. And divide 0 by 4, and you still have 0. Okay, so this is much simpler, much easier to work with. I can just, again, just factor this and say that I have y here and y here. So I'm going to say this is what? This is a perfect square trinomial. It factors into y minus 4 quantity squared. Okay, so your solution here for y is just 4. So we know y is 4. So let's figure out what x is. All right, so I'm just going to plug into the top equation. I'm going to plug in a 4 here and here. So I would have x squared plus 8x. And then I would have minus, what's y squared? Well, I'm plugging in a 4. 4 squared is 16. And then you have plus 10 times 4 would be 40. And then minus 33 equals 0. So let's go ahead and crank this out real quick. Negative 16 plus 40 is 24. And 24 minus 33 is negative 9. So I'm just going to erase this and put minus 9 there and then equals 0. Okay, let me make that a little better. Again, we have something we can solve using factoring. So pretty easy overall. If you want two integers that sum to 8 and give me a product of negative 9, well, I know I would want to use positive 9 and negative 1. So the solutions here for x would be negative 9 and positive 1. Okay, x plus 9 equals 0. The solution is x equals negative 9. X minus 1 equals 0. The solution is x equals positive 1. So I would say that you have one ordered pair that would be negative 9, again, the solution here, and then comma 4, that y value, and another that would be 1, comma 4, that y value. Okay, so two solutions. Again, I've already checked these. I know they work. Once again, you always want to check your solutions. All right, for the last problem we're going to look at, it's going to be another one that's extremely tedious, and we're going to use a combination of elimination and substitution again. So we have 3xy minus 2y squared equals negative 2. We have 9x squared plus 4y squared equals 10. So in this bottom equation, you have two variables that are squared. In the top equation, you have an x to the first power and a y to the first power and then a y squared. So the strategy here is to get rid of that y squared, and I can do that with elimination. Okay, so that's the first step. So I'm going to multiply the first equation by 2. So I'm going to have 6xy and then minus 4y squared. This equals negative 4. Okay, just multiplied everything by 2. Let me just write this one again. So 9x squared plus 4y squared equals 10. If I add these two together, then I'd have 9x squared plus 6xy. And then this cancels, and it would be equal to 6. Now, before you go any further, realize that you could divide everything in this equation by 3. So 9 divided by 3 is 3. So this would be 3x squared. 6xy divided by 3 would be 2xy, so plus 2xy. And this equals 6 divided by 3 would be 2. Okay, so I always want to work with something as simple as possible. Now, I can take this guy right here, and I can solve it for y. Okay, so the way I would do that is I would subtract 3x squared away from each side. And that would give me 2xy is equal to negative 3x squared, and then plus 2. Okay, so I have that, and then I could divide both sides by 2x. And let me erase this up here, and I'll say what? That y is equal to this negative 3x squared plus 2 over 2x. Okay, so we got that figured out. Now, where do we go from here? Well, what I want to do is plug into this equation here. I'm going to plug in for y. So what that's going to give me is 9x squared plus 4 times this guy. I'm going to put parentheses around it, so negative 3x squared, and then plus 2 over 2x, and this guy squared. So be very careful here. And then this is equal to 10. So this is going to require some work. So let's scroll down a bit. So let's think about this for a second. Forget about the 4. Let's just focus on this part right here. So if I had negative 3x squared plus 2 over 2x, and again, if this was squared, then it's really like I had 2 of them, right? So negative 3x squared plus 2 over 2x. Well, how do we multiply two fractions or two rational expressions? All I need to do is multiply the numerators together, put that over the product of the denominators. So this guy is just negative 3x squared plus 2 quantity squared, right? So the first one would be squared. So the negative 3 squared is 9. x squared squared is x to the 4th power. And then after I do that, it's 2 times this guy times this guy, okay? So I know it's minus 2 times 3 times 2. Well, 2 times 3 is 6. 6 times 2 is 12. And then times that x squared, okay? And then you would have plus this last guy squared, which in this case, 2 squared is 4, okay? And then over 2x times 2x is 4x squared. Okay, so we've got that worked out. Now let me drag this up here. And when you work these, you want to have a lot of scratch paper because you got a lot of stuff you got to go through. So if I have 4 times this, the 4s are going to cancel. So let me just erase this. Let me put equals 10 down here. And I'm going to get rid of this and just substitute in what I have. So get rid of that. And let's just drag this up here now. And that's going to be our simplified equation. And what I want to do, if I want to solve for x, I got to get rid of this x squared in the denominator. So if I multiply through by x squared, what's going to happen is we would have 9x squared times x squared, which is 9x to the 4th power, okay? Then it would cancel down here, so I'm just left with this numerator here. So plus 9x to the 4th power minus 12x squared plus 4. This equals, I'd multiply this by x squared, so 10x squared. So again, all I did was multiply both sides of the equation by x squared to clear that denominator. All right, so at this point, we can solve this for x. I'm going to subtract 10x squared away from each side of the equation. And I'm going to say that 9x to the 4th power plus 9x to the 4th power is 18x to the 4th power. Negative 12x squared minus 10x squared would be minus 22x squared. Then we have plus 4, and of course this cancels, so it's equal to 0. You can immediately see that, again, we can divide everything by 2. And so this would be 9x to the 4th power minus 11x squared plus 2 equals 0. Now, this can be factored. You can use a lot of different techniques to factor this. You could easily use substitution, where you let u equal x squared, and then you can plug in and go through all that. Because of the length of this video already, I'm just going to give you the factored form and say this is going to be 9x squared minus 2, so that quantity, times you have x squared minus 1. And of course, this can further be broken down into x plus 1, and I forgot the 1 there, times x minus 1, okay? So you've got to go through and set each factor equal to 0. And so what will we have? Well, we know for these two it's really easy. The solution here would be that x is equal to 1 or negative 1. So that takes care of those two. But for this one, you need to do a little bit more work. So 9x squared minus 2 equals 0. Add 2 to both sides of the equation. Let's just go ahead and say this is 9x squared is equal to 2. Divide both sides by 9. And you would have x squared equals 2 ninths. So if I take the square root of this side and plus or minus the square root of this side, I would have what? You would have that x is equal to plus or minus the square root of 2 over the square root of 9 is 3. So that's a lot of different things to go through. So you have x equals 1, negative 1, square root of 2 over 3, and negative square root of 2 over 3. So we would say square root of 2 over 3 and negative square root of 2 over 3. All right, so we come back up here, and I'm going to use this that we found earlier, that y was equal to this guy right here. You can plug into these equations up here. This is going to be a lot quicker, a lot easier, so that's why I'm going to do it this way. All right, so if I plugged in a 1, we know that we would get what? Let me kind of do this off to the side. Y would be equal to 1 squared is 1, so negative 3 plus 2, which is going to be negative 1, over 2 times 1, which is 2, so negative 1/2. So if x is 1, y is negative 1/2. All right, what about for negative 1? Well, you would have negative 3 times negative 1 squared is 1, so you just have negative 3 plus 2, so that's negative 1. But then down here, 2 times negative 1 would be negative 2, so this is positive 1/2. So if x is negative 1, then y is positive 1/2. So let's get rid of these two, and let's work with these two now. If I had negative 3 times this guy squared, so you'd have the square root of 2 over 3, this guy squared, plus 2, and this is all over 2 times square root of 2 over 3. So if I squared the square root of 2, I would get 2. If I squared 3, I would get 9. So this would be 2/9. So this would be 2/9. If I divide 9 by 3, I get 3. So this would just be -1, and this would be 3. So this would turn out to be -2/3. So -2/3. Okay. So now from here we have +2. So let me get a common denominator going. I'm just going to multiply this by 3 over 3. So this would be 6/3. So plus 6/3. And of course this would end up being 4/3. So that's my numerator. I have 4/3. So down here, what am I going to have? Just 2 times square root of 2 over 3. Okay. So let's simplify this by just saying that we have 4 over 3 times the reciprocal of this, which would be 3 over 2 times square root of 2. Okay, so let's erase this. What do we get? Well, this would cancel with this and give me a 2. And this would cancel with this. So what I'd have is 2 over the square root of 2. And if you rationalize the denominator there, if I multiply this by square root of 2 and this by square root of 2, then what I'm going to end up with is what? This would end up being 2 down here. And of course I can cancel this. So I'd end up with just the square root of 2. So if I had the square root of 2 over 3, then I would get the square root of 2. Okay? So now we have one more to check. And I know this is tedious, but again, you're going to get problems like these, so you might as well work some. So the last one, let me just get some room going. We would have the negative square root of 2 over 3. If I squared that, again, I'd have -3 times, in this case, the negative would go away. Square root of 2 squared is 2, so this would just be 2/9. And we know that this would cancel and become -2/3. So this is -2/3 plus 2. And again, we wrote that as 6/3, so this became 4/3. So that's, again, the numerator. So it's 4/3. Then over 2 times this guy, which is now negative. So I would have -2 times square root of 2 over 3. Okay, so let's get rid of this. And of course, this turns into what? 4 over 3 times -2 times square root of 2 going in the denominator. Up here, you'd have your 3. Okay, so let's erase this. And let's go ahead and cancel this with this and this with this and say it's a 2 here. So what you have here, let me just kind of write this over here. We'll say this is -2 over square root of 2. Again, you want to rationalize. So if I multiply this by square root of 2 over square root of 2, square root of 2 times square root of 2 is 2. And this would be -2 times square root of 2. We can cancel this with this and just say we have the negative square root of 2. So this would be negative square root of 2 over 3. And then comma, you'd have negative square root of 2. Let me erase this. And those would be our answers. Again, I've already checked this. When you're working these, you got to make sure you check them. I know it's really, really tedious. It takes a lot of work to check them. But you could report a wrong answer if you don't. So here we get 1 comma -1/2, -1 comma 1/2, square root of 2 over 3 comma square root of 2, and then negative square root of 2 over 3 comma negative square root of 2. In this lesson, we want to talk about systems of inequalities. All right, so the main idea here, if you're solving a system of inequalities, you're going to sketch the graph of each inequality, and then you're going to look for the overlap of the two graphs. That's going to give you your solution for the system because it's the area of the coordinate plane that satisfies both inequalities of your system. So we're going to start with an easy example. We have two linear inequalities in two variables. We have -3x plus y is less than or equal to -5. We have y is greater than or equal to x minus 4. Now, you can use the test point method or you can solve for y. Whichever you want to use, I'll cover both. Let's solve for y first because it's a bit easier. So what I'm going to do is I'm going to add 3x to both sides of this inequality. And this will give me y is less than or equal to, I'll have 3x minus 5. Okay, this one's already solved for y. So y is greater than or equal to x minus 4. Okay, so the reason you solve for y is if you've solved for y, you can look at the inequality and tell which direction you need to shade. Okay, in a moment, I'm going to talk about a boundary line. So once you have that, you look at your inequality. Again, if this is solved for y only, and you say, is this a less than or is this a greater than? Okay, so it could be a less than or equal to. That means you shade below the line. okay? If it's a greater than or equal to, you shade above the line. It's very easy to remember. A less than or equal to, you shade below the line. Greater than or equal to, you shade above the line. Now, when we talk about this boundary line, all it is we take our inequality and we replace the inequality symbol with an equality symbol. So in this case, we have y equals 3x minus 5. So we'd graph that. In this case, we'd have y equals x minus 4. Okay, so what is the boundary line? Well, basically, it separates your coordinate plane into two regions. One where all the points, all the x comma y ordered pairs are going to satisfy your inequality. So if you plug those into the original inequality, you would get a true statement. The other region, which is on the other side of the boundary line, none of the points are going to work. Okay, so if you plug it in, you're going to get a false statement. Okay, so that's the test point method. We'll talk about that in a moment. But essentially, you graph your boundary line. Okay, so you just sketch the line like if you were normally graphing this guy. And then again, if you have a less than or equal to, you shade below. If you have a greater than or equal to, you shade above. Okay, now one last thing. When you work with a boundary line, if it's a strict inequality, meaning you have strictly less than or strictly greater than, you want to put a broken or dashed line because in this case, your boundary line is not part of the solution set. Okay, it's strictly less than or strictly greater than. Okay, in this case, we have non-strict inequalities. We have less than or equal to, and we have greater than or equal to. So because of the or equal to part, we want to include the boundary line in our solution set so it's a solid line. Okay. So let's go ahead and graph y equals 3x minus 5, and then we would shade below the line because this is again, less than or equal to. So I've already done this to kind of speed it up, but again, we have y is less than or equal to 3x minus 5. The boundary line is y equals 3x minus 5, and again, it's solid because this is non-strict. So we know it's in slope-intercept form, so the y-intercept is 0, negative 5. So go down to 0, negative 5. That's your point on the line. And then you can say, okay, well, the slope is 3. So go up 1, 2, 3 to the right 1, up 1, 2, 3 to the right 1, so on and so forth. Sketch that line. Now, because this is a less than or equal to, and because we've solved for y, we shade below the line. So I'm going to shade everything below the line. So that's my shading that's already done for us. But again, if you're doing this on your own, you just want to shade below the line. Okay, let's talk a little bit about this test point method. If you come back up here, let's say you didn't solve this for y, you sketch this, negative 3x plus y is equal to negative 5, you get the same boundary line, okay? Now, if you have this graph, and let's say you pick a point. Let's say you pick 0, 0 because it's easy to work with. If you plug it in, it's not going to work. How do I know it's not going to work? Because it's not in the solution region. Again, I talked about the fact that you're either in the solution region or you're in the non-solution region. We already know that below the line here is the solution region. This 0, 0 at the origin is above the line, okay? So it's going to be in the non-solution region. So if I plugged it in, I should get a false statement. So if I said, what is negative 3 times 0? Well, that's 0. Plus 0, well, that's 0, okay? And is 0 less than or equal to negative 5? Well, no. 0 is greater than negative 5, and 0 is not equal to negative 5, so that's a false statement. Okay, this is false. So if you plug in a point like 0, 0, and it fails, right, you know you're in the non-solution region. So if I use the test point method, I plug in that point, it doesn't work, so I know I need to shade on the opposite side of that line, okay? If it does work, I shade on that side of the line. So that's another way you can get this shading here, again, below this line. Okay, the other one was y is greater than or equal to x minus 4. Again, the boundary line is y equals x minus 4. Okay, and I've drawn these two together, and basically what we're going to see here is that, okay, let me write this out. So y is greater than or equal to x minus 4. The boundary line y equals x minus 4. Again, to graph this, the y-intercept is at 0, negative 4. So we'll come down here. Let me pick a new color. Let me pick this color here. So that's going to be right there, right? So 0, negative 4. The slope is 1. So I can go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, so on and so forth. I get this point and this point. You know how to sketch the graph of that line already. Now again, because this is a greater than or equal to, I want to shade above this line. So I'm going to shade in this direction, okay? So I have each of these already done, right, in terms of the shading. for the orange line, remember we were shading below. Okay, we were shading below. So if we think about the area of the coordinate plane now that satisfies both, what do we have? What is below the orange line and also above this green, or again turquoise line? Well, it's going to be this area right here. Okay, this area right here. And to highlight this a little better, I have a cleaner graph where this is clearly shown. Okay, so this is the area of the coordinate plane that is below the orange line and above this, again, I'm just going to call it a green line. Okay, so this is the area of the coordinate plane that is the solution for both, okay, simultaneously. And so it's the solution for your system. Okay, it's got to satisfy both. So you can pick any point, okay, in the shaded area, plug it into both inequalities of the system, and it's going to give you a true statement in each case. Let's look at an example where we have a non-linear system. So this is where you have at least one non-linear inequality, okay? So we're going to have to work with a parabola, and then we're also going to have a line, but you can have many types of shapes. You can have a hyperbola and an ellipse. You can have a parabola. You can have all kinds of different shapes, all the things we've worked with so far. So we have y is greater than or equal to x squared minus 4x minus 1. We have negative 2x plus y is less than or equal to negative 5. So for this one, it's very easy. We would just solve it for y. So y is less than or equal to, you've got your add 2x to both sides, so 2x and then minus 5, okay? So your boundary line is y equals 2x minus 5, and again, it's solid because this is non-strict, okay? So we would graph this and shade below, right? Because this y is less than or equal to. So graph that and shade below. So we have y, again, is equal to 2x minus 5, and y is less than or equal to 2x minus 5. So this is the graph, okay, this boundary line of y equals 2x minus 5. Again, my y-intercept is at 0, negative 5. My slope is 2, right? So I'm going to go up 1, 2 to the right 1, up 1, 2 to the right 1, you know, so on and so forth. You get that line. And because this is less than or equal to, I want to shade below. So that's where I got that shading from. So we're shading below the line. Okay, let's go back up. Let's think about this parabola now. So this is a little bit more difficult. We can just erase this. We don't need it anymore. We have y is greater than or equal to x squared minus 4x minus 1. So when you start getting things that are more complex shapes, a lot of times it's easier just to use a test point, right? Because you might not be able to think about, well, where is y greater than in this case? Well, for a parabola, it's going to be shading inside of the parabola, okay? And if it's less than, then you want to shade outside of the parabola. Okay, but you can also use a test point to show that. But for this guy, for the boundary, you just, again, use an equality symbol. So y equals x squared minus 4x minus 1. To graph this, it's easiest to put it in your vertex form. Okay, so we already know how to do this at this point. So we would say y is equal to a, which in this case is 1, times the quantity x minus h squared plus k. So again, where does h come from? Where does k come from? H is what? The vertex formula tells us this negative b over 2a. So what is b? B is the coefficient on x to the first power. So the negative of negative 4 is 4. Let me change that to this. And then a is 1, so 2 times 1 is 2. 4 over 2 is 2. Okay, so I know that h is 2. You can plug that in. How do we get k? Well, it's f of 2 in this case, right? I know I have the y notation, but basically you're just plugging in a 2 for x and see what you get. So 2 squared is 4. Then minus 4 times 2 is going to be minus 8. And basically what you have is 4 minus 8 is negative 4. Minus 1 is negative 5, right? So this is minus 5 here. So once we have it in this format, we know that the vertex occurs at 2, negative 5, okay? 2, negative 5. Now, from there, you can use your step pattern. Again, this is 1. So you plot the vertex, and then you go 1, 3, 5, 7, 9. Remember that step pattern. So you go 1 unit to the right, then 1 unit up. 1 unit to the right, 3 units up. 1 unit to the right, 5 units up. And again, you can reflect across your axis of symmetry to get points on the other side, okay? So I've already pre-drawn everything. Let me just copy this real quick, and we'll go down to the graph. And let me just paste this in so we know what we're working with. Again, this was y equals the quantity x minus 2 squared and then minus 5, okay? So the vertex, again, is at 2, negative 5. So if we go to 2, comma, -5, that's going to be right here. Then again, you can use your step pattern. So you go to the right one, up 1. Then to the right one, up 1, 2, 3. Okay. Then to the right one, up 1, 2, 3, 4, 5. Then you can reflect across your axis of symmetry, which would be that line, which is x is equal to 2. Okay, that's your axis of symmetry. So you reflect across, you would get this point and this point. Okay, and that basically gives you enough to sketch the graph of your parabola. It's going to be solid because this is non-strict. Okay, so the same rule holds whether you're graphing a line, an ellipse, whatever it is. If you have a non-strict inequality, make it solid. Okay, if it's a strict inequality, make it dashed or broken. All right, so once we have this, again, if you have a greater than or equal to or greater than, and you're working with a parabola, just shade inside the parabola. So you're going to shade inside the parabola, okay? But the other way to get this, if this is confusing for you, and I know a lot of students struggle with that, what you can do is you can just take a test point. So in this case, 0, 0 is inside the parabola. So you can use that. If I plugged in a 0 for x and a 0 for y, and we get 0 is greater than or equal to -1, which is true. So I know I want to shade inside of the parabola, okay? If you pick a point outside of the parabola, it's not going to work, okay? So that tells you you're in the non-solution region, okay? So you think about this parabola here as separating the coordinate plane into 2 regions. Inside the parabola, outside the parabola, okay? So if I pick something like, let's say, -1, 0, so -1, 0, it shouldn't work. So this would be 0 is greater than or equal to, -1 squared is 1. You have -4 times -1, which is 4, and then -1. Well, 1 plus 4 is 5. 5 minus 1 is 4. So this says 0 is greater than or equal to 4, which is false, okay? And you can see that's false because it's outside of your solution region, okay? So this shouldn't work, and it doesn't. So that's where we get these two graphs, okay? And we put them together. So where's the overlap between the two? You're shading inside of the parabola, okay? And you're shading below this line, okay? You're shading below this line. So where's the overlap between the two? Again, if I continue this shading inside, you can see it's this small area. And let me kind of shade this a little bit better. It's this small area in here, okay? And I've made a better graph so that we can see this more cleanly. You see this area here that's highlighted is below the orange line and still inside of your parabola. So that satisfies both inequalities of the system, and so it's your solution.